Hello everyone, my name is Ali Hantal. I am the Senior Testbed Coordinator at OpenAI Cloud Association, also known as OARC. I would like to welcome you all to this online tutorial by OpenAI Cloud on this very first day of ISMAR 2021. And I would like to invite to the stage now Mr. Jan-Erik Vinje, the Managing Director at OpenAI Cloud, for his opening remarks.
Hello, everyone. My name is Jan-Erik Vinje, the Managing Director of the OpenAI Cloud Association, and I have the honor and privilege to welcome you to this online tutorial. Today's topic is an open architecture for combining the virtual and the real at the city scale. Our organization has developed an experimental platform and a reference architecture consisting of open source implementations and protocols for a few essential spatial computing services. We call this the Open Spatial Computing Platform, or OSCP for short. We really would have wished that we could have done this in person in the city of Bari, because Bari is not only the location of the ISMAR 2021 conference, but it is also the place where a little over 1 year ago, the very first city-scale testbed for the OSCP was started. Our partner Augmented City has scanned more than 100 square kilometers of Bari for their visual positioning service and added many thousands of AR objects that can be discovered and experienced using a smartphone. Importantly, Augmented City has made their positioning and content services compliant with the protocols of the OSCP, allowing others to add their own content and develop and create their own experiences running on the platform. We would have loved to let everyone who attends this tutorial be able to experiment with implementing city-scale use cases and being able to immediately test their solutions in the Bari testbed. However, when things are the way they are, this might be an opportunity for you to bring the OSCP platform home to where you live and work. It is actually easier than you might think. And in this tutorial, you will have the opportunity to learn how. So I will first introduce some of the key concepts related to the AR cloud and the motivations behind our platform. But the actual tutorial is going to be held by this all-star team of key contributors to the OSCP effort. The first one following me will be James Jackson. He is OARC's Director of Technology and the main architect of the OSCP. Then you will hear from Ali C. Hantal, the recently appointed Senior Testbed Coordinator for OSCP, who also this summer, through his company XR Masters, published the very first OSCP-compliant spatial browser app in the Apple App Store and the Google Play Store. Next is Mikel Salazar, an OARC volunteer and key contributor to the OGC Geopost Standards Working Group, an essential standards effort that is intended to be at the very core of the OSCP. Mikel holds a PhD and is a research scientist focusing on interactive 3D and XR technology. Then you will meet with Julia C. Biebout, CEO of Novabee, a company that recently implemented a spectacular artistic experience running on the OSCP in downtown San Francisco. After her is Gabor Soros, a research scientist at Nokia Bell Labs. For the last few months, he has been leading the latest developments on the OARC's open source Sparkle web client that connects a smartphone browser to the OSCP. He has also put together a demo paper for ISMAR about Sparkle that you should definitely check out. Lastly, we have Michaela Di Vietro, who is coordinated Augmented Cities R&D efforts in computer vision, spatial computing, and machine learning. Without the support of Michaela and the Augmented City team, we would not have had the opportunity to start the OSCP testbed in Bari or hold this tutorial for ISMAR 2021. Today's agenda is divided into 3 sessions that are roughly 1 hour each. In the first session, we will provide a high-level intro to the platform. I start out with an overview of OARC or AR Cloud technology and the rationale behind the Oscp. James will give the architecture overview of the platform, and Ali will attempt a live demo of content placement for the Oscp. So beware. In the second session, we go more in depth. Mikkel will provide insight into OGC Geopost standards effort. Julia will teach you how to do great scans of locations to enable visual positioning services. Gabor will help you get a deeper understanding of our spatial discovery services. And Ali will show you how to upload and manage content for the Oscp. In the third session, we will show you how you can build client apps that connects to the Oscp. Gabor will show you how to set up the dev environment for Sparkle and show some demos made with Sparkle for the ISMAR conference. Michaela will walk you through the Augmented City SDK integration for building native apps running on the Oscp. Before I delve into my stuff, I would like to say a couple of words about the OpenAir Cloud Association for those who haven't heard about us. OARC has, up until now, just until recently, been an entirely volunteer-run organization. So we're a global nonprofit that advocates for open standards and interoperability, as well as ethical best practices in the technology domains that connects the real and the digital worlds. Since our founding in 2018, over 300 individuals and 60+ organizations have joined our organization. In addition to developing the Oscp, we have published the 150-page State-of-the-Art Cloud report written by 40 authors. We have held 3 in-person symposiums, both in Europe and the US. Our members are actively participating in a number of standards development initiatives in different standards bodies, of which the Open Geospatial Consortium Standards Working Group on a Universal Geopost encoding is one of our most important volunteers' contribution efforts. So in addition to the all-star team you will hear from today, there is a passionate volunteer community that has been doing a lot of great work over the last few years. It is amazing what can be done by passionate volunteers in their free time. But it is also a fact that to make more rapid progress, it is helpful to pay people to do full-time work. The great news is that we have just won our first R&D grant, and we are happy to say that we will be able to hire research engineers that will be properly paid. So we are hiring, and if one of you in the audience today would be interested in doing Oscp-related research, you should consider sending us your CV right away, because the project will start very soon. Just chiming in there that there will be some information on now that we have now that we have done the introductions and looked at the schedule for today, now we're moving over to trying to explain the concept of AR clouds. And I have been allowed to steal some slides from Christine Perret. She has been a regular attendee at ISMAR for many years, and she did another tutorial earlier today on open standards and interoperability. So let's start out with the large-scale concepts. We have ubiquitous computing, and we also have spatial computing that has some overlap. And we want to try and explain AR cloud technology in this wider context. Ubiquitous computing is a term that has been around for many decades, And very much today, we're living in this ubiquitous computing world where we have our smartphones with us. We have computers all around in our home, in our cars, in our workplaces, in our factories, in our, everywhere. The term itself, it describes something that is pervasive, it is omnipresent, it is everywhere. And definitely that's sort of the world we're in now, with computing everywhere. Spatial computing is a little bit different. So this is computing that relates to the physical volumes and the objects within it and how they relate to the space. You have also, importantly, a geospatial aspect where we can relate those objects and the phenomena in the real world to geospatially anchored locations and places. So there's a shift in spatial computing where before we had interaction with data that was sort of dislocated from the space. It was all around, but it didn't have a connection directly with the space you were in. With spatial computing, you are immersed in a three-dimensional relationship with the data. So the data describes the world itself, and it describes the relationships between you and other data in the physical surrounding. You can imagine that there's atoms, and you describe those atoms, and you can imagine representing objects, and then you could represent relationships between the objects, and ultimately our relationships with the objects in the real world, both digital and physical. So this is sort of the transition. Definitely across industries, there's a big convergence around spatial computing, in particular real-world spatial computing. An important part of that is world understanding. So you see more and more the use of reality capture and the use of machine learning and semantic technologies to understand the world around. So imagine a tree, you capture that tree. Now you have point cloud data, and you can segment that point cloud data, and you have a representation of the whole tree, and you have the different parts of that tree, like the trunk and the branches and the leaves or the roots. Now you can imagine some other entity in the world. You identify that object, and you know something about what this is. This is a bird, so winged flying being, and you know that there's a typical behavior associated with this bird and how it relates to the tree, where it tends to like to fly to a branch and sit on that branch. So with all of that in our minds, now we can try and define AR cloud. AR cloud technology really is essentially the creation and management of persistent, dynamical, three-dimensional, machine-readable representations of the world. So it is the physical space, and you also, when you do this shared representation, then you can have multiple users who are interacting and having AR experiences in the physical world. The most fundamental aspect, of course, is the mapping. You capture the world, you capture the atoms and represent them. Now to make these AR clouds, not just on your device, you need networking, and you need cloud and edge cloud resources. Now you can start to do processing and try and analyze the data, do stuff like determining the position and orientation, the 6 degrees of freedom pose of users. You could assign different types of experiences that unfold as you move through the space. So you can bring up relevant experiences and content as you move through the space. This is a representation of the AR Cloud framework that Christine Perret described in the State of the Art Cloud report. And essentially, you put the data at the center, and then you have different types of computing on that data that connects with your AR, the user, devices and the user experiences in the context of the wider physical world. So part of this story is that you use the new technologies of 5G edge clouds. So you have low latency, you have high capacity, and then you have compute and storage that is much closer to you. That is essential for the kind of low latency demands that XR has. This obviously isn't limited to AR. The whole thing that is happening in Industry 4.0 with industrial IoT leverage the same kind of distributed networking and compute architectures. And for what that means for AR cloud is that you have the opportunity to split the representation of the physical world into two parts, where you have a static layer that is the terrain and the buildings and things that doesn't move, that you could put out in the big classic old school cloud. But for all the stuff that is real time, obviously it's good to have it technically closer, as it reduces the latency and you have more optimal economics. It scales better. But importantly, it also allows people to and businesses to have their local data on their device or on the edge compute nodes, so that it is less of a risk of being exploited and used for nefarious purposes. So with the reality layers put in the context of the cloud technology and edge cloud technology, we also have the opportunity to service many industry verticals. So this is the stuff that is not necessarily the atoms. This is the culture, this is the commerce, this is the future, this is the past that you can bring into and summon into the real world for all kinds of purposes. Also, it's important to make the distinction between the type of AR you have traditionally, this on-device AR, not connected, and then you have the AR clouds. So you can do persistent if you're on device, but it's very limited. You have to do it yourself on the fly, and it's hard to make it scale across users. With AR cloud, you can persist experiences in the real world and share that with many users. Also, as you move through the scenery, you run into some issues if you try to put everything on your device. It is limited what you can store and what kind of services you can support when you're not connected. So definitely, as you move through and have a continuous contextual search, that is really only possible with an AR cloud setup. And yeah, the sharing of experiences, you can do that maybe with a couple of people right next to you. But how about thousands of users? No possible way could you do that just on device. You need this kind of infrastructure. And obviously, for the positioning technology, you could have your local map. You download a little map, but it is limited. So as you start to move through space, you run out of space. You need to have new maps or build new maps. And it's only through AR Cloud's technology that this is feasible in any sensible way. Obviously, the big companies, they understand that this is a big, important shift in technology, and the investments are massive. If you look at what they're building and the amounts that are being invested, like Facebook 2019, 5 billion into spatial computing, it's plausible estimates. It is not going down, has not gone down the last few years, I can tell you, with COVID. Microsoft, Google, everyone, you recognize the features of AR cloud technology in the visions that they are presenting. So isn't that just great? Well, there is this problem that the big players currently, what we see is that they are playing this like a zero-sum game. They're building their own platforms. And those platforms, they aren't designed to work across the other platforms with the other platforms and be interoperable. So they tend to create lock-ins. They have proprietary walled garden solutions that just don't work together. That's a very, I would say, poor solution that people in general, they wouldn't ask for that. They would much rather have it like the web. And also you have the aspect of this being very powerful technology. It's a double-edged sword. You could move towards more of a digital renaissance where the positive potential is maximized. There's also this risk that populations could be captured in Black Mirror scenarios, so XR ethics. We don't know if these large corporations are the best to manage this transition into this technology future in their current business models. So the one of the obvious approaches to do something better is to get inspiration for what has worked before. We really know that Tim Berners-Lee, when he came up with the web platform, consisting of a few open protocols and standards, it really scaled. It really created this universal compute that has dramatically affected everything that we do. And it isn't a lock-in platform. There are issues. He's working on that when it comes to the big centralized clouds companies. So it's not the only solution, but that is really essential. This is where open spatial computing platform takes its inspiration. It's sort of like a keep it simple, stupid approach, where we're looking at the really essential things we need at least to start building this kind of future. So we want to converge on some kinds of protocols and standards that we can use for positioning in the machine readable world and for spatial discovery. An essential part of our platform is Geopos, geospatial 6 degrees of freedom, position, and orientation. There's a working group in the OGC that is developing a universal Geopost encoding standard. And it started its work in January 24th, 2020. The OGC Architecture Board just recently approved a draft for public review. So this is going to be exciting. OpenAI Cloud, as previously mentioned, our members are actively engaging with a lot of different standards bodies, trying to participate in working groups, trying to coordinate for future standard development efforts. So we want to converge on shared standards rather than creating a confusing mix of new non-interoperable standards. With that, let's leave it over to James Jackson for a deep dive into the architecture of the open spatial computing platform.
Thank you, Jan-Erik. Now, I would like to invite James Jackson, the Director of Technology at OpenAI Cloud, for his presentation on Open Spatial Computing Platform Components and Architecture.
Hi, James Jackson here. I serve as the Volunteer Director of Technology at OpenAI Cloud, and I'm going to drill into some of the details behind our Open Spatial Compute Platform. So one of the core philosophies of OpenAI Cloud is to build open source reference implementations that help move the industry ahead. What I'm showing here is the high-level architecture of OSCP. Starting off at the top, you see that we have services that are homed to the country level, such as Spatial Service Discovery. And then lower down, we have services that exist in what we call a geo zone. A geozone could be a town or a city, and most likely these services would live very close to the users, so in some sort of an edge cloud as an example. Now, touching on the color scheme here, you'll notice we have some services shown in yellow, which are fully specified by Oscp. And what this means is that we define not only the APIs and the data models, but also the internal design and implementation details. That's the case for services such as Spatial Discovery. We have others that are shown in gray, where these are partially specified. For these, our focus is more around the interoperability rather than the actual internal implementations. So we focus on the data model, the APIs, the data exchange, but there may be a whole range of different implementations from proprietary implementations to open implementations. And this is the case for services such as Geopos and reality modeling. So let's step through the typical flow of a client interacting with these services, right? So imagine that we've got a user wearing smart glasses. Most likely this is 5G connected. So we need the characteristics of a 5G environment, high bandwidth, low latency. And as I mentioned, these services most likely reside in some form of an edge cloud. So we've got Oscp client libraries that are interacting with the services. Our very first step is to query Spatial Service Discovery. And Spatial Service Discovery is essentially going to help us discover these lower level services that are available in the geozone. You could think of Spatial Service Discovery as being similar to a DNS hierarchy. So it may be homed to a particular country and operated by some sort of foundation. But essentially, it's a mapping of coverage polygons and their associated services. So the characteristics for those services, the URLs to contact those services, etc. Once we've discovered which services are available, we move on to the next step, which is finding our Geopos. Geopos is really an accurate representation of our position and orientation in a common real-world coordinate system. Now, we've been working with the Open Geospatial Consortium, the OGC, on specifying a standard representation for Geopos. We've also defined a Geopos positioning protocol. This is essentially a localization protocol that allows clients to stream sensor data into a positioning service. This could be information such as camera images, IMU data, GPS information, essentially any sensor data that helps with the positioning task. The positioning service then in turn provides the Geopos associated with the client. And again, that's the accurate position, ideally down to centimeters, and accurate orientation of where you're facing to within a few degrees. Now, Geopos services today are largely based on vision or computer vision approaches. You'll often hear these referred to as visual positioning services. And we have several partners, including Augmented City and Immersal, that have implemented support for the Geopos representation, as well as this Geopos localization protocol. And they've also implemented support for interacting with our spatial discovery services. So now that we have our Geopos, we know precisely where we are in the real world. The next step is to discover spatial content. And spatial content discovery allows us to do this. Spatial content discovery helps us find virtual content like 2D or 3D assets that are anchored in the real world, or even richer immersive spatial experiences that have some jumping off point in the real world. Spatial content discovery and also spatial service discovery are really using lightweight JSON records and spatial content discovery has pointers to external content. So the content itself doesn't live in the service. And then there is a Geopos associated with that content, so we can accurately anchor the content in the real world. Both service discovery and content discovery are designed on a decentralized web fabric. The idea here is that we want to allow multiple providers to contribute to a shared spatial index. You could think about this as being sort of like web search for the spatial web, where we're trying to democratize this idea of search. We want to ensure that anything that is indexed is available to all users who have permissions to see it. So we avoid this idea of silos where you only see content depending on which particular ecosystem you're connected to. So now that you've discovered the spatial content, we move on to the very last step here, which is reality modeling. Reality modeling is still very much so an emerging concept. There's a lot of work here to do, and it's in the early stages. But reality modeling is where this digital twin of the real world ultimately lives. The digital twin includes static layers such as your roads and your buildings, but it also includes dynamic layers such as people and cars, and a real-time representation of, you know, where they are and how they're moving and interacting at any given moment. You can imagine that there's a tremendous possibility for future research in this field and new services that will evolve as a result of this. We envision that we get to a mode where, you know, you've got this rich semantic understanding of the real world and even how objects relate to each other through dynamic scene graphs and things like that. But you know, in its simple form, you can imagine a structured model of the real world where you've got publishers and subscribers for that data, right? So you've got people that are contributing to building the model, and then you've got clients that are subscribing to a feed of that model. If you take one of the simplest use cases today, that might be occlusion. So if I've discovered all this content through spatial content discovery, but perhaps there's a tree or a building between me and the content, then I ideally shouldn't be showing that to the user, right? The richer these spatial experiences become, the more important it is for them to interact seamlessly with the real world around them. Now, some of these other services that I'm showing here in orange, like the actual content hosting or some of the higher level intelligence around the specific experiences, as well as cloud rendering, are not specified by Oscp, but they're certainly important pieces of the overall pipeline. So moving on to some of the specific details, we'll start with spatial services discovery. As I mentioned, you can imagine this as 2D coverage polygons and their associated services. Here you see a sample map showing some of those coverage polygons. You can see that there is a REST API that provides access to this data. And over here, we have actually a sample spatial services record. And you'll notice that it's using standard GeoJSON to define the polygon. The actual coordinates aren't shown here to save space. And then we've got some characteristics for the services. In this case, it's a Geopost service, and this is how we contact it. I've listed here the GitHub repos for the services, so the core service itself, which, as I mentioned, is built on this decentralized web infrastructure. There's a running prototype of it hosted in AWS where you can experiment. Anyone has read access to this, so you can try some of these values. You would need an account to be able to create records. And then there's a client library that facilitates efficient interaction with the service. Similarly, for spatial content discovery, in this case, we're discovering the actual virtual content in the real world. You see here in this example that we've pulled in a 3D model of Bender. This is a GLB of Bender and the associated Geopos for him. So we can now place him accurately in the real world. Again, you'll see that it's standard REST API, and we have an example of the spatial content record here. So you see the reference to the GLB that was pulled in and the associated Geopost. Once again, we've got the GitHub repo for the core service, running prototypes hosted in AWS, and client libraries for simple interaction. This shows sort of the high-level topology around spatial discovery. So as I mentioned, you've got spatial service discovery, which is homed to a given country. So, first we have to determine which country's spatial service discovery service we're connecting to, right? That top level may be operated by some form of foundation. And then we've got multiple providers in a given country contributing to this common index. And again, this is service discovery, right? Now we use service discovery to discover the other services that exist in the geozone. So then we drill down to a particular geozone or city. I'm showing some examples here, Helsinki, Finland, and Bari, Italy, because this is where some of our partners are running real testbeds today. So we've got Immersal running a live testbed in Helsinki, Finland, and Augmented City running a testbed in Bari, Italy. What you'll see here is that we've got geozone-specific services, such as spatial content discovery. Again, you can have multiple providers in that geozone contributing to a common index for the content. And you can have multiple Geopost providers and communicate with them via that standard Geopost protocol. I mentioned a decentralized web technology, and today that is based on the Hypercore protocol. You could think of this as being in ways similar to Git, but you're synchronizing all changes in real time, and it's designed to deal with very large amounts of data. We also use certain implementations of a decentralized OpenStreetMap architecture for the core today. And this last one is Geopost. So I mentioned that it's the representation as well as the localization protocol. If you look at the GitHub repo for Geopost, you will essentially see a specification for the protocol itself. So that essentially defines how you provide and structure all your sensor data that is provided to the Geopost service, and then the Geopost structured response that comes back. This is implemented today by several of our partners. In addition to the core repo, you will find client libraries, again, specific to Geopost. And there's an excellent demo that you can look at here, which essentially walks you through the stages of discovering a Geopost service through spatial services discovery, connecting to that Geopost service and providing image data, getting your Geopost back in response, and then placing that particular image in the real world based on the Geopost in a 3D tiles model. So let me touch a bit on the future. These are very early days for us in Oscp, and there's a tremendous amount of work to be done. So we encourage anyone that's interested to come and join us and help contribute to this vision. Some of these items are maybe smaller efforts, and some of them, as you'll notice, are much larger, right? So this first one is around an idea of having restrictions on spatial mapping and augmentation. So we think it's really important that we be able to control a particular setting, such as your home or your business, and that you have policies that dictate who's allowed to map in those areas, who's allowed to access maps, who's allowed to create augmented content, to view augmented content, right? And a lot of that can be at the highest level controlled through a special set of service records. Along similar lines, we start off thinking of the public first scenarios when we follow the web model, but of course, private and hybrid scenarios are also very important. So again, going back to the example of your home or your business, you most likely don't want this data to be public, right? So there's this aspect of a decentralized identity scheme and being able to control precisely who has access to which pieces. So that's going to be a very important piece of integration or architecture to evolve going forward. We'd like to look at creating an open source reference Geopos localization service. So we're working with some of our university partners and other OR partners on this effort. As I mentioned, Geopos services may be proprietary, they may be open, there is no set standard around this, and the idea behind the reference service is that it helps foster some R&D and innovation in this particular space. Very important aspect is the deployment topologies of these various components, how they fit into a 5G world, an edge cloud world, how distributed that particular edge cloud is, how close it is to the end devices, as well as moving functions between end device and between edge cloud. So there's some intelligent split that can occur here for different services. So there's a lot of work to do around prototyping these deployment architectures, ideally in real world test beds with 5G and edge cloud available. I mentioned visual positioning services, but visual positioning is only one particular modality. There are many different ways of doing positioning. As an example, in autonomous driving, you often use LiDAR sensors, right? It turns out that with 5G millimeter wave, it's theoretically possible to get very precise position and orientation information through trilateration type schemes. The standards around this are still evolving and not quite available in the real world yet, but we expect to be seeing them over the next few years. So it's interesting to think about some of these other positioning technologies, and it's not as if one is better than the other. They really complement each other in different scenarios. So you can imagine sort of hybrid architectures. Some technologies work better in rain, some better in indoors versus outdoors, or at night versus during the day, right? So it's very interesting to look at this mix as we move forward. I mentioned that reality modeling is really in the early stages. So at this point, there is no standard modeling language and no standard protocol to specify the communication associated with that language and how we move towards this idea of a shared model of reality. So there's a tremendous amount of work that has to be done in this space. And that includes not only the data model and how we interact with it, but this whole aspect of spatial data exchange, right? The same may apply to positioning services. Ultimately, you can imagine that that spatial data on the back end sort of converges the data that's used for localization, which today is more so sparse point clouds, versus the data that's used in your reality model, which might be more of a structured representation of the real world, right? But we see that sort of coming together. And then the important aspect being the creation of a spatial data exchange around all of this information, and doing it in such a way that, of course, we honor the privacy of the end users and make sure that it's an incredibly secure environment. So thank you again for your time, and we encourage you to join us on this journey. Thanks.
Thank you, James, for going over in detail the Oscp components and architecture. Now, I will be showing a few videos about AR Cloud examples and how persistent and shared AR experiences can be created using the Open Spatial Computing platform. I will then take you to my dining room for a live demo on how to do on-site authoring or content placement using our mobile application. But first, let me introduce myself. My name is Ali Hantal. As I said at the beginning, I serve as the testbed coordinator for Open Spatial Computing platform at OpenAI Cloud. And I am also the founder of XR Masters, which is the company to develop the first and only OSCP compliant authoring and browser application. The first example is an AR wayfinding experience, which was created as a POC at an airport. The user was asked to type in his flight information, and then he goes and holds his phone still to get localized. And he starts seeing spatial ads on his left, right in front of the Samsonite. He saw that ad. And then he can see an AR panel which shows his flight information, TK2319, and his gate. And then on his right, he sees this Vodafone spatial ad. Then while he's looking and going towards his gate, he sees that social distancing sign on the left. And again, while he's following the arrows on, he sees another spatial ad which gives about a 50% discount for that jewelry shop on the right. As you can see, the arrows are taking him towards his gate, but he sees another ad. On his left is a restaurant ad which says, "Come and taste this." Now on his left, while he's walking to his gate, he sees that there is another ad spatially located right in front of a shop which sells watches. And he continues to walk. Remember, his gate was 238, and the AR wayfinding support gets him to his gate at 238. Think about how this would be helpful for those people who are flying through an international hub, which is a very crowded one, and those who do not speak English or foreign languages well are really scared to travel internationally. The second video is actually a very striking one, as it shows how user experience will change in the new spatial web era, where AR content can perceive and feel things and their surroundings and act accordingly. On the second video, the clownfish on this video senses where the user is and runs away from the user as he or she gets closer to it. This is one way of showing how AR content will perceive its surroundings. We can call this as proximity-based content activation. We can also have sensor-based content activation, where the AR content can be activated when a door, for example, is opened if there are sensors installed. This clownfish can go out when the door is opened, and don't go out and stay inside when it's closed. Or we can create an experience where the user can activate content by simply gazing at it. This way, we can actually create different scenarios and experiences for each user depending on where they gaze first. In other words, objects on the scene can all trigger other layers of content. And this way, user experience can be unique depending on which object they gaze at first. The last video on this slide shows dynamically created AR nodes that the user can pick the duration at the time of the creation. You can see that the user is typing a message and then chooses the duration of the message. In this case for 1 hour, and boom, you can see that there is this spatially located content at the user's kitchen. This can also be developed in a way that the user can choose by whom this content can be viewed. For instance, this note is being placed by a user for her husband to view when he comes home. This is another video that I will be showing. This is actually the last one for this section. It's a very good example of how an AR cloud experience can be more realistic by occlusion. You can see that the clownfish is being occluded by the building while it is swimming behind it. And this brings me to the live demo. Now, let me change my screen sharing to my phone and walk towards our dining room.
Hold on, let me get out of these. Yes. I am walking towards my dining room. Let me get the camera. I think everybody can see me. And let me share my screen. So what I'm doing is right now I will be starting AR, which will localize. And please note that I have scanned this environment using Augmented City Scanner app. And now you can see that content has been just around me, and there is this little space exhibition going on in my dining room. And what I'll be doing is first show you how I will actually delete everything on the screen, and then I will go to my place content menu. And please note that if when you are going to be working with Oscp, you will need to register to XR Masters app and send us your information so that we can make you an editor. And before that, you would need to use Augmented City Scanner to scan the environment. So I clicked on place content, and now I am going to just alter, place an ISMAR logo. And there are 4 features that I can do, 4 functions that I can do. One is I can rotate, The other one is I can resize, and I can click on the very left and I can actually get his height as I want it. Let me just leave it right there and place it. You can see that my AR Cloud content, which is persistent and shared, actually has been placed. So what I'll do is let me start AR again, and right there after localization, you can see that ISMAR logo is right there. And this is actually a way to do it. There is also other menu items. You can place AR note. And again, when you click on manage content, you can see what you have just placed. What I will be doing now is I'm coming back to my computer for a Q&A session. And let me get out of this and join the audio again through my computer. I hope you are hearing me fine back there. And if you have any questions right now, I can see Julia. Are there any questions, or Gabor on the Discord channel?
Yes. So we have a person asking about the positioning service that's used in your airport example.
Positioning?
Yes, it says, can you say which position service is used for the airport example? Can you hear me?
Yeah, that example has been done using Augmented Cities localization services. So we scanned the airport using Augmented City Scanner app. And actually, you will be learning from Julia in detail how you will get a quality point cloud of the location in our next session. And that's what we used. Augmented City has a great localization service.
Yeah, so everyone, please feel free to type your questions into the Zoom chat. We're trying to keep the whole session together that way. So feel free to elevate those there, and we will pass those on to the appropriate person. Let's see here. I think the other thing, Gabor, maybe you could just elaborate a little bit. You put a good comment into the chat about the Geopost scheme, and maybe explain that. We'll be talking a little bit about that more later. So, you know, for the attendees, please tune into the later sessions if possible. But perhaps you can just say a quick word about that. Looked like there was some questions. Are you there, Gabor? A lot of people. Or Ali or Jan-Erik, if you want to just chime in a little bit about what Geopos is.
I can try this one. There was a question about GeoURL and GeoDNS. So as Gabor mentioned, those things currently they don't take the full 6 degrees of freedom. They might still be relevant in some way. So there's no we're not excluding any opportunities for interoperability. And there's this whole previous history of geospatial locations, POI data and everything that could work very well together with the open spatial computing platform. So we are open to looking into any way we can make our platform as interoperable as possible.
And Mikhail, in the second session, Mikhail Salazar will be doing a full presentation on Geopos. So you can get a lot more information on that. And we are recording all of the sessions.
So I noticed there was another one on and the SDS, if it's like equivalent to ICANN. And Gabor and myself, we tried to answer that we're still in this very early phase where the platform isn't at a level where we would sort of officially hand it over to like foundations or that kind of thing. That is more like the proper location for handling universal infrastructure. At some point in time, those kinds of discussions should happen. But let's first get this platform up and running and demonstrate on a technical level and get some feedback from the wider community on what they think about the platform.
And I'm just going to play timekeeper here. So we have reached the time for the end of the first session. So we do want to allow people a 5-minute break. Session 2 will be beginning in about 5 minutes. So that is at 15:40 Central European time. For those in the US Pacific time, that's at 6:40 a.m. And the first session there will be on Geopos by Mikkel Salazar.
Thank you, everyone. So we'll be back in 5 minutes.
I'll be hanging around here. So if you have further questions, feel free. Also, I'd like to say that you should give an applause to Ali who did the live demo. Yeah, it works. It's stable enough to do live demos, and that's a good sign.
Always risky and scary. Did a good job.
Yeah, Murphy's Law didn't work today. I am so glad that it did.
Yeah, you'll probably be speaking more about this, but you mentioned, Ali, that there's a possibility for people to first download the app you demonstrated from the App Store, but to do the things that you did, you need special user permissions. So maybe you can tell people how to reach you if they attendees here, if they want to use that feature of your application.
Sure. Yeah, I will be talking about that, but that's okay. Like we're saying, basically, there are 2 apps required for this experience to be able to create experiences on AR Cloud using Open Spatial Computing platform. And one of them is Augmented City. And for Augmented City Scanner app, they will need to contact Augmented City team to actually receive a test flight app for an iPhone and an APK file, because that application is not on the stores. And Julia is going to talk about how to scan the surrounding, and she will have a great teaching there about how to get the best quality point cloud of your location for localization. And then the next thing you should be doing is contacting us after downloading XR Masters app, which is available for free to download both on Apple App Store and Google Play Stores. Once you do that, we would ask you to please register as a user. And when you register, then we will ask you to send an email to development@xr-masters.com. And let me type this here. It's development@xr-masters.com. And
maybe label it with the email, label it with something with ISMAR.
Yeah, if you can subject ISMAR 2021 OARC tutorial, and then please give us your email address that you registered with, and we will give you the rights for editing, and that will give you rights to not only place content, but also manage content. Now, in between, there is a step that I will be talking in detail, is you need to upload your AR content to XR Masters content database. And that is upload.xr masters.com, and you can actually upload Unity asset bundles to using that URL, upload.xr-masters.com, xr-masters.com, and you will be uploading 2 different asset bundles, one for iOS and one for Android. And then as soon as you upload them, you'll be able to see that on the XR Masters placement menu, content placement menu, like I did just a few minutes ago. So there is detailed documentation, and I'll be also sharing our GitHub repository for that, the link for that during the PowerPoint presentation, and that will be just an easy way to follow how to create, if not ever before, your first AR cloud experience utilizing open spatial computing platform.
I think we're approaching, it's not far from when Mikael's presentation will start.
Yes, I think we're at 6:40, so why don't we move to session 2?
Okay, can you hear me?
Yes.
Oh,
Yes.
Yeah. Perfect. So,
And Mikael Salazar will be presenting on understanding Geopos. Here you go, Mikael.
Okay, can you see my screen?
Yes.
Okay, so hello everyone. My name is Mikael Salazar, and I am here to present Geopos. Sorry, a new standard from the Open Geospatial Consortium that aims to provide a simple way to define the pose, that is, the position and orientation of an entity in relation to the Earth via a geographical reference frame. The goal of this standardization effort is to create a common logic model and JSON encodings that everyone can use to convey the position and orientation of all kinds of entities, both virtual and physical in nature. A standard that is especially relevant for mixed reality developers because apart from posing virtual objects on top of the real world, it enables us to create new and more intuitive interaction techniques with the camera of the device, game controllers, or even robotic systems like drones or autonomous vehicles. But yeah, but I know what you are thinking. Don't we already have many standards that deal with these things like latitude and longitude? Isn't creating another standard focus on this redundant? Heck, you can even say that you know how to place something on top of a sphere. You only get the longitude and latitude, convert them to radians, calculate the similar cosinus, and apply basic trigonometry. And just by applying basic things, this in one single instruction, you can generate a transform and be able to even apply further translations and rotations, and you have placed a virtual object on a sphere. That's right, but the real world is not as perfect as a sphere. After all, we are the recent volcanic eruptions remind us that we are floating on top of a spinning ball of magma in an uncaring cold universe. This means that sadly the world is not flat, and gravity is not really as constant as we would like. Something that poses a problem when you are designing things like a big road network, and the 3D scheme doesn't account for the curvature of the Earth, resulting in roads floating over the terrain a few kilometers away. Plus, the terrain is in constant movement, even without landslides or earthquakes. Thanks to plate tectonics, the surface of the Earth is not completely submerged underwater, but it also means that almost every point on Earth moves a few centimeters every year, making it nearly impossible to anchor a virtual object to a specific location with enough precision for human interaction, not for more than a few months at least. So, for these reasons, most current standards focus on geolocating entities at a specific point in time rather than truly posing them. For example, a standard like AFC only allows you to define the rotation of a building around the vertical axis. You don't have 6 degrees of freedom. On the other hand, some standards used in the aerospace industry have 6 degrees of freedom, but like the NASA Spice Toolkit offers so many options, requires so many parameters to define the relativistic frames of reference that are way too difficult for most developers to use. So here comes the OGC Geopost standard that as a solution to these problems, Geopost aims to provide a universal logic model that can easily be referenced in other standards, while providing developers with JSON encodings that allow them to create interoperable systems that can talk between each other without much friction. However, it is important to mention that it is the OGC, the Open Geospatial Consortium, who is behind the creation of this new standard, which means that once it is fully ratified and implemented, it will enable everyone to access to a veritable treasure trove of GIS data that has been gathering dust for decades. And in the future, it will also allow the data to be easily updated without developers having to worry about things like how the lunar cycle affects the convection forces within the core of the planet. Nothing about that. You don't have to worry. But how can we use Geopost in augmented reality applications? Well, the evident use case is to use Geopost to store the position and orientation of virtual objects without the need of markers, fiducial or otherwise. Additionally, while Geopost doesn't yet specify a way to directly define motion paths, that doesn't mean that you can use Geoposes to define the path of a moving object. In fact, it can be a simple way to share the intended path of an entity, such as a drone or an autonomous vehicle, so that the different agents can plan their routes in real time and avoid accidental collisions. Yet, the most important application of Geopost will probably be the camera tracking. Thanks to Geopost, multiple systems, like the visual positioning system that James mentioned before, can be used to estimate the pose of the device with great accuracy and precision, giving the user a seamless augmented reality experience across the entire planet. And this is why Geopost is such an important component in the open spatial computing platform. But while there is a single conceptual model, in the Geopost standardization working group, we are trying to limit the complexity of the data encodings by generating multiple JSON schemas for different use cases. Most of the time, 90%, 95% of the time, one of the basic encodings will be more than enough to satisfy the requirements. But if you need to deal with additional frame transformations, the advanced form of the Geopost provides multiple ways to specify the required parameters. And finally, the complex Geopost form are intended to help geospatial engineers to address problems that require multiple transformations without the need of a scene graph that we graphic programmers usually take for granted. But if you are thinking why there are two versions of the basic Geopost form, well, this is a good example of why it is so important to have different point of view when defining a standard. Because initially, Euler angles were considered to easily define the orientation of entities within the Geopost standard. However, specifying the names of the axes, the left and right hand rules, and the order with each rotation should be applied resulted in all kind of problems. For this reason, the standardization group decided that to instead use quaternions to define the orientation system due to the different types of interpolation that they allow. Yet, the fact that quaternions are four-dimensional complex numbers made working directly with them actually dangerous, because not only they are not able to encode relative rotations beyond 180 degrees without problems by adding several of them, but the different values are interconnected with a complex formula and cannot be directly modified by a human being in an emergency. So those values, you have to change the four of them, or you have to use an external tool. That's why I analyzed different standards and proposed the use of the aircraft-based access system that it is commonly used in the aerospace industry for the rotation. In this way, it is possible to maintain the simplicity of the Euler angles while also avoiding the gimbal lock issues and increasing the internal consistency of the data structure, since the latitude and longitude values are also expressed in degrees. So basically, with this system, everything is a degree except the altitude value or the height over ellipsoid. Nevertheless, this kind of change requires feedback to be properly implemented. So if you do not want to calculate the square root of a complex number each time you want to debug a minor issue, I invite you to take active part in our meetings and voice your opinion as users and developers. The version 1.0 of the Geopost standard has recently been ratified in the OGC, the OGC architecture board for public review, and we are working on guides to help you take advantage of this standard. In the meantime, I implore you to participate in the standard working group meetings and give us feedback, especially if you are a graphic programmer, because the evil geospatial engineers are attempting to redefine important terms such as height or transform. And if you don't want to deal with those redefinitions in the future, now is the time to act. So thank you for your attention. And if you have, if there are any questions in Discord or in Zoom, Julia, please let me know.
Yeah, we will be having a Q&A session at the end of this session as well. And now we are inviting Julia Bivat from Novaby for her presentation on creating a quality point cloud for localization.
We cannot hear you.
Yeah.
Help if I unmute myself. Can you hear me now?
Yes.
Okay.
We can hear you now, Julia, but you should reshare. Yes.
Okay.
Yes.
Can you see my screen now?
Yeah.
Yes, we can.
Okay, great. Well, good morning, everybody. Good afternoon, your time. I'm actually coming from the West Coast of the United States, so it's very, very early my time, but I'm excited to be here with you all and to talk to you about how to create a quality point cloud. This is really one of the first steps in the workflow. So you can think of here's a quick depiction of the workflow. So basically you get an idea, you have an idea and you have a space that you want to put this idea in. And the point cloud creation, like I said, is one of the first steps that you do. So basically you're going to scan an area, and what this will enable the system to do is for your phone or whatever device you're using to recognize where you are and localize based on that, and then visually position the content within that so that it appears correct from your perspective. The other key components, which Ali is going to be talking about, are a content management system, which XR Masters has developed a robust system for that. And that involves content placement, content delivery, and content hosting. He'll be elaborating on that. But ultimately, all of this goes into an end user experience that can be, say, a spatial browser type of experience, which Ali showed earlier. They can be rich interactive experiences. They can be mobile phone or wearable based, and they can be app or web based. So we're going to be focusing right now on point cloud creation. And to do that, this is something that's a lot easier to do than to explain. So I think the best way to talk through this is to go through an example of a project that we've been working on in Seattle. And so you can see here, this is a location, and it's going to be a public art and history tour in Seattle, and you can see the location here. Here's kind of a architectural rendering to show the space, to give you an idea of the type of space that this will be going into and that we scan. And the great thing about this is you can see there's a lot of rich data, a lot of rich visual data in this space, and it's also relatively permanent and fixed, meaning it does not change. So here's a photo of the real space with our beautiful Seattle weather. And so here again, you can kind of see this is ultimately the point cloud that was created with this, and I'll be walking through how we did that. As you get more practiced at looking at these, you can see actually the individual components that I have drawn out here. So here is the building that you were just looking at. Here's that circular open area, the other building, and also the trees. So again, you can get used to seeing these as you move forward. So to create this, there's a few concepts and terminology that are helpful to understand. So the first is a location. And so basically a location is a collection of points that you've scanned. I'm using terminology on this. I used the Augmented City Scanner app to create this scan. Again, so I'm kind of using their terminology, but it is consistent across different types of scan apps and stuff that you can and will be using. So, and then there's multiple passages. The thing to keep in mind with passages is that these are really for you, the user, to organize your scanning and content. There's a minimum of 1 pass per location that needs to be taken. And then a passage is really a collection of points. You need a minimum of 2 points to create a passage and ultimately create a location, but generally you're going to need to create a lot more than that. The key component to realize on this too, though, is that you do need a separate calibration scan to make this all work. That took me a while to understand that the calibration is actually not related to the location, not necessarily related to the location you're scanning. So the sole purpose of the calibration is basically to get the measurement system that your phone uses aligned with the measurement system that your scanning app is using. So to calibrate, basically you're going to walk about 10 feet or scan some points that are about 10 feet away. And the idea is that you're just trying to define for the scanning app what is 10 feet. So that you could actually do a calibration at home or anywhere else. It doesn't have to be on your site. So you could set those up in advance if you like. After you've done your calibration, you can begin scanning your points. So this is where you do want to be on site of the place that you're scanning. And here I used circular scans for this, meaning I stood in a point and turned around. But you're basically going to create multiple points. And then those points begin to collect into what's called a passage. And again, the main purpose of passages is for you to organize how you're scanning your area or your location so that you can kind of track what you've done and completed. And then finally, as you finish your passages, you will then finish your location and you're going to upload those to the server. So again, kind of walking through this specific example, and a little bit easier to demonstrate than to explain. So this is where I created the calibration scan. So why did I pick this spot? So again, it had nice rich data here. There was low reflections, meaning the camera could get a good scan, and I could get a nice 10-foot space and walk along that to create the calibration run. The nice thing about Augmented City Scanner is it does tell you when it has enough pictures to create the calibration. And so it has a lot of good feedback that way. From there, I moved into the plaza area to begin scanning this whole area. Again, I used a circular mode. You can use a linear mode, but most applications or situations, the circular mode is probably going to be the right choice for you. Some key things to think about there is, again, what we're trying to capture are things that are permanent features in the environment that have a low risk of changing. And so organic objects, for instance, or dynamic movable objects are not good choices. So here, again, there's a lot of rich data on the buildings. And the key there is to kind of keep your phone slightly tilted up. You're trying to capture the vertical areas, basically. You can capture the ground, but the issue there is that the ground, things can change quickly on the ground if things are down there and all that. So again, this is surfaces that are unlikely to change. The other key thing to realize is that your camera is actually capturing more information than you're seeing in your screen. So even though it may look like you're just capturing this picture, say from here to here, you're actually capturing much further. From there, after you do your first point, you're just going to continue scanning additional points. There is guidance in the application for how far to move for each point. For me, I just kind of follow a simple rule of moving about 6 feet or 2 meters every time I create a new point. That works really well. There's not you can't scan too many points. Definitely the more information, the better for a good quality point cloud. However, that does obviously impact the upload time and the file size of what you're capturing. So that was the first pass. Then I created a second pass, created of multiple points. And then the upload process. So after I had created my passes, then you need to upload it to Augmented City's server to process all of those pictures. The thing to realize when you're doing a scan is even though you're moving and you're taking pictures, it's actually not taking video, it's taking individual pictures, and they're combining those into an overall point cloud. And so a few things to realize is you want to really keep each of your locations below 2,000 pictures. So a collection of 2,000 pictures. And that's really just gets into the limitation of uploading and processing at a given time. I've made the mistake of going over 2,000 pictures before, and while in theory it's possible, it is not recommended from a processing or uploading time. So for a large location like this, you are actually going to probably have to divide it into multiple smaller locations because of this 2,000 picture limit per location scan. Other key things to see here is, you can monitor, how long it's taking to upload. It can take a while depending on the size of how many pictures you've taken for your scan, but it is getting faster and faster over time. The key thing you want to keep an eye on is this number here. This tells you your success rate. You need a minimum success rate of 75% for it to be a good quality scan. The higher, the better. Generally above 90, you want to be shooting for above 90%. So if it comes back below, after it's processed, below 75%, you'll actually have to rescan that area. You may want to consider rescanning if you get below a 90% as well, but that's optional. The other thing to realize too is for their scanner, there is a pro mode. I do recommend that. There's an auto mode and a pro mode. The auto mode basically kind of takes the pictures for you as you scan. And if you're an absolute beginner, that may be the way to go. But I think for most people, the pro mode is actually very intuitive and it can be a lot faster. So basically you're controlling when and where the pictures are being taken. And here you can see the end product of your scan. So in the rectangular picture is actually kind of the high resolution scan, much more recognizable as the site and location that I was scanning. What's ultimately used in the visual positioning systems and browsers is a low density point cloud. So the high density is on the left, and this is extracted from that. And then, so just if you have questions, actually, there's help in the app itself, which is very good. It's the little question mark on the lower left-hand corner. And then you're certainly welcome to reach out to any of us, and myself in particular. So with that, I will hand it back over to Ali.
Thank you, Julia. So we will have Gabor Soros presenting on understanding content and service discovery.
Hi everyone, my name is Gabor and I will add some more details on spatial service and spatial content discovery. As shown by the presentation of James, when a client first starts up in somewhere in the world, it doesn't really know where it is and what kind of services are available in the neighborhood. So it first goes to the service discovery, spatial service discovery, which will return a number of services available in that area. Among these services, there can be localization services, content discovery services, and many other kinds of services. So the client first goes to the first available localization service. It determines its own pose, and then with the known pose, it goes to the content services and searches for content based on users' preferences. These four highlighted components here are already implemented and are open sourced and are all covered in this tutorial today. Right now, I will focus on these two, spatial service discovery and spatial content discovery. Let's start with spatial service discovery, or abbreviated as SSD. This stores geozones, basically polygons of the world map, and associated services as URLs. The records can be synced between multiple servers if this is needed in a peer-to-peer manner. We defined so far 3 different types of services: Geopost services, content discovery services, or peer-to-peer master services, which I will talk about in a later section today. The code of a reference implementation for SSD is available in this GitHub repo, and a client library written in JavaScript is available in the SSD access URL. We also provide a running service and a Swagger interface to try it out. And I will show it in a second how it works. The coverage areas are defined as GeoJSON protocols, GeoJSON entries. You can look at examples here at geojson.io. This simply shows a map, and you can very easily click a few points and define a polygon, and this is written on the right side. So when we create new services, we usually just copy paste this polygon into the service descriptions. Throughout the Open Spatial Computing platform, we use H3 indices for describing the location of the user. This is a hierarchical location index developed by Uber. It's a multi-level hexagonal grid covering the surface of the Earth with the highest resolution up to 1 square meter. But we use a much coarser resolution. For the purpose of not exposing the real GPS coordinates or the real location of the user at any time to the platform. So even if the client itself can determine its GPS coordinates with the platform, only the H3 index is communicated. H3 is good for like it's a hexagonal grid, and it's good for searching because all the neighbors are in the same distance. Let's see an example of a content entry or service entries. We can go to this website, which I have here open. The one SSD Oscp Cloudpost.io, and we can try a GET request. Let's see, I am currently located in Budapest in Hungary, but the spatial service discovery is running in the US, so I have to write US here, and I have to copy paste my H3 index. I'm cheating here. Let's see, execute, and let's see what kind of services are available around me. Oh, as we see here, there are 3 services found. There's one Budapest Center Geopos, which has a link, a URL to Augmented City service, localization service, and there is also a content discovery service, which again links to Augmented City, but at a different endpoint. This is to retrieve the contents. We can have other kinds of metadata properties, like what kind of topics are available in this service. And there's a third service for peer-to-peer connection, which I will talk about later. This is the Polygon Geologism defining the coverage area. And as you see here, multiple services can belong to the same area, and some metadata here, altitude of the map, or who created and when this entry. With a post request, we could also create new services, new coverage areas, but this requires authentication at the moment on this server. For this tutorial, we also set up another instance without authentication, so you can actually try and play with it. Let's go back to the presentation. Here is an example response, just as described. So it's important here that multiple services can belong to the same area. And this is what we call spatial service record, these ones. So that we don't have to create these links manually, we created an admin tool, a web interface, which creates these get and post requests for us, and has a nice map interface, which is also open source. So the tool itself can be compiled, and the code is here in the Oscp admin repo. This is how it looks like. We can define these coverage polygons and add some services. It is important that if you want to try out the system in this tutorial during this week or even after, please contact us, or you need to register if you want us to add your coverage area to our SSD, or you can run and fire up your own SSD instance, and then you can add any kind of services you like to that one. As James already mentioned, the whole system, the whole discovery system would work like the domain name service, where some top-level instance, like similar to the top-level domain, would get the original requests and forward them to the running instances. And multiple of these instances, for example, this can be grouped by country and country, and these multiple services can be synced together in a peer-to-peer manner. The idea here is that everyone has access to all the entries, and it's not the providers who filter these, but the clients should actually select what they are interested in. And let's take the example of Bari, where we deployed this whole system for the ISMA conference. This service has a content service in Bari and a Geopost service in Bari, but there can be actually multiple providers of each of these. The spatial content discovery is the other type of service, which works very similarly. It contains records of content with the associated Geopos. So contents can be anything like 3D models, 2D info stickers, or points of interest, but also more complex scene descriptions, or just a URL to other experiences and larger contents. It also contains a Geopos and some metadata: who created, when, what kind of topics this record belongs to. This is, we call it spatial content record on SCR. This is how it looks like for a hotel or restaurant at this location. Geopos is now not shown here. And another protocol proposed by the Oscp is this Geocross Protocol, which is a standardized or like proposed way of doing visual positioning, uploading in a request, a Geopos request, the available sensor readings. Here the client has one camera and one geolocation sensor, and these sensor readings contain a photo taken by the camera, encoded in base64 string, and latitude, longitude, GPS readings. And these would go up in a request to the Geopost service, which somehow magically determines the 6-degree of freedom geopose of the camera and returns it in this JSON format. You can take a look at the description in this Oscp Geopost protocol repository. The whole more details on the proposed sensor types, more complex queries, and so on. As I mentioned, we have running instances at this address, but we also set up just for the tutorial another instance without authentication. And please reach out to us if you are interested in setting this up for yourself. You can read our documentation at this link and check out the code. Thank you very much, and now up for Q&A.
Thank you, Gabor, for the detailed information on spatial content discovery and spatial service discovery. Now, I'll be talking about spatial content authoring. But before that, let's go over what we have gone through so far. Earlier today, James Jackson, the Director of Technology at OIRC, presented on the Open Spatial Computing platform, and he went over this slide to show the high-level architecture. Then Michael Salazar talked about Geopos, and as just recently, we heard from Gabor on spatial content discovery and spatial service discovery. We also heard from Julia about how to create a quality point cloud of the environment for localization using Augmented Cities Scanner app. She also went over this slide to show the workflow from idea phase to creating a full-blown AR cloud experience. I will come back to this slide, but let me first explain the relationship between OIRC, Augmented City, and XR Masters. Both Augmented City and XR Masters are technology partners of OSCP, OpenAR Cloud, and Augmented City is the first and the only OSCP compliant localization service provider. And XR Masters mobile app is the first and the only OSCP compliant spatial content authoring and browsing application. There is also the Webxr client for OSCP, which is called Sparkle AR, about which you will be learning at the next session. Here's the workflow slide again from Julia's presentation. This slide shows the flow starting from the idea phase to scanning or digital mapping your environment, to uploading and placing your content, and finally visualizing or browsing your AR placement. Julia went over in detail how to use Augmented Cities Scanner app. Here, I would like to remind everyone that if you are interested in acquiring this app, you will need to reach out to Augmented City and request a test flight invite for the iPhone app and the APK file for the Android version. And you can do that at OIRC's Discord channel. We'll be pasting this to the chat during the Q&A session. You can always ask us after the presentation as well. And this is where Julia stopped. That dotted line, the blue dotted line. In other words, we are at this blue dotted line, and by now, mapping and scanning your environment has been covered. The next step will be to upload your content. And for that, you will need to visit upload.xr-masters.com. Then, for placing and authoring your content and browsing through what you have placed, you can use XR Masters app, available on both Apple App Store and Google Play Store. And you can find detailed information and documentation on all of these on OIRC's GitHub repository at this link, which is here on the slide. We'll also be pasting this link on the chat, and please feel free to ask us on our Discord channel. To summarize, I would like to state that currently, by utilizing Augmented City Scanner app and XR Masters app, anyone can digitally map his or her environment and author AR content as desired and view or browse the content using the same app. Here, I would like to also let everyone know that content authoring can also be done remotely using Augmented City's administrative back office. And this will conclude my presentation, which will bring us the end of session 2. It is now time for questions. I think Jan-Erik has been and Mikael has been writing back and forth. And Anthony, does he have any questions right now that we should address? Jan-Erik?
Yeah, there was discussions around what type of ways to represent the orientation of an object. So I'm also in the same working group. I'm a co-chair along with Christine Perret, and maybe I should turn on the camera, and Jerry Morley, who is Chief Geospatial Scientist at the British Ordnance Survey. And there's this larger group there. And we have this comprehensive logical model that can cover a lot of different ways to encode position and orientation. And then we have, between this logical model and the implementation targets, there is like a logical structure that is a little bit more abstract, that isn't a precise encoding format. But we have 8 of those right now, and we think they should cover most. So 2 of them are for the basic cases. Currently, we have one that has quaternion and one that has Euler angles. So we haven't made like a final decision on using just one, or if we should keep 2 options, or if we should add a third one. But OpenAI Cloud, so far, we are siding with the quaternion way of representing orientation. So in the open spatial computing platform, right now we're using quaternion. That is based a little bit on the research that the working group has done on prior systems. So if you look at both prior commercial systems and open source systems, when they represent pose, what is most common is to use quaternions. And as Mikael has said, there are drawbacks with looking at a quaternion. It's not very intuitive. So this is more at the system level. So our thinking is that if you want to make a user interface, well, bring up Euler angles or more intuitive angles to the user by doing some conversion. But in the system and communicating between systems, we believe that there's like more developers would favor to avoid having this conversion step when they're communicating from system A to system B. That's our reasoning. So you're definitely, you could go into the GitHub repo of the Open Geospatial Consortium, and you could post issues and chime in on your opinion on this topic.
Yeah, boils down to, should be a Geopos be actually human readable apart from a system readable, because humans cannot deal with quaternions by the very nature of the complex nature of the quaternion. But whatever decision you have, we have to abide by.
So things are not set in stone, and those who might have opinions, they are free to discuss that in the GitHub issues on the OGC GitHub on the standard.
I don't see any other questions. Please type in. We still have a few minutes if you would like to ask any questions. And if not, we can have a break again. And Julia, as the timekeeper, how long should we get the break?
Oh, there's another question from Anthony Steed.
Okay.
It is for Julia. Would you like to answer that? How do you set the geopose of the scan?
Oh, yeah, actually, I'm probably going to let Michaela chime in on that. So there's really, for the scanning phase, there's really nothing for the scanner, the user, to do with that. So basically what's happening is when that information, when those scans or photos get uploaded, Augmented City's system is also recording where you are and is binding that geographically with any relevant Geopos data on their side. So there's nothing for you to do on that. But I will let Michaela chime in as the Augmented City person that could maybe elaborate a bit more on how those things are done. Michaela, you're on mute.
Yes. Basically, you using our application, you don't set anything regarding Geopos, but automatically there is a special passage dedicated to calibrate. So automatically the system calibrates your everything. But you don't set anything regarding Geopos in this application.
Yeah. So again, that gets to that calibration pass that you do at the beginning that we talked about. Yeah. So yes. It's really important. Okay, I think let's see, we've got a few more minutes for questions in this session. The next session will be starting at let's see, what is that? 7:40 my time, so 16:40 Central European time. So we've got about 12 minutes before the beginning of the next session. You're welcome to stay around and ask questions during the intro.
Michaela, do her presentation now.
Okay, I'm sharing my screen.
Okay, great.
You can see everything?
Yes.
I think yes.
Michaela, okay. we can see, yes.
Okay, perfect. Hi, everybody. My name is Michaela, and I'm a technical project lead for Augmented City, the Italian startup dedicated to implement software solution mainly based on Air Cloud. I'll provide you some technical information regarding open sample AR application called AC Viewer that allow you to localize and show several kinds of content, from simple sticker, video object, and even 3D animated models. Anyway, AC Viewer is a part of a global, our global platform that consists in a free SDK for developers, AR software solutions, mobile applications. And now I'll show you how download the source code of AC Viewer, and also how create the software environment to run it. Also, I'll show you to build AC project, AC Viewer project, and how created, generating an asset bundle in order to add your 3D content in the previously scanned places using our tools, like, for example, AC Scanner, that our tool for scanning surrounding objects. AC Viewer is a Unity-based system project. So you need to install, first of all, a Unity editor. I suggest you to use Unity Hub because that is a standalone application to manage manage your Unity project and installations. Very, very easy. Here is reporting the minimum version of a Unity, but you can use also higher versions. This version is reported also in our README file. And clicking three-dot button to the right to the Unity version, you can also install select and install several modules in order to create the software environment for our project. Here, you can see our website. Visiting our webpage, you can find several information regarding our SDK, API, including the link to download our source code of AC Viewer. And this is our repository. Just clicking to the code button or using the git clone command, you can download it on your PC, the project. Well, here are listed some preliminary steps. You have just using Unity Hub, open your project, downloaded project, and clicking this arrow, you can also select several other versions of Unity. Anyway, AC Viewer SDK is based on AR Foundation system. So after install, of course, the Unity Hub, you have installed other dependencies, for example, for Android or iOS. In fact, our SD Viewer runs on several devices, so you need to install other dependencies listed here. And in this slide, you can see a screenshot of our project. On the left here, you can see the demo scene that you open and build. And on the bottom side, you can find the chosen version. In this case, I choose not minimum version, but another version reported. Another version. So there are also a list of other versions of AR Foundation. Of course, the version of these packages depends on your installed Unity editor. Well, to run AC Viewer to get the application on your device, you have set up your project and choose your dependencies independence of the chosen platform. For example, we are for both platform, you have put hello unsafe code true. And in case of Android platform, it's necessary to delete Vulkanian API for graphics API because our code doesn't support it. In case of build for iOS, of course, you have to set install, for example, ARKit XR plugin in order to build also for this platform. And here is there is a screenshot showing where you can find this particular setting. This is a Windows related to project setting. If you would like to build for Android, for example, of course, you have to create the software environment to do this, to perform also this build. And you have to check in preferences external tool, like shown in this slide, if are present, there are several installation. For example, you need Android SDK tool and also the Android native development kit installed via Unity. This is the recommendation for you. And I reposted on the left side some useful link, for example, regarding Unity Gradle support, and also how you can download this particular version of Gradle. Performance check your dependencies. You can perform the build just clicking on File and later Building Settings. If you choose the Android platform, please check again Player Settings. In particular, you have check your dependencies, indicated lights here in the blue color. For iOS, you would have to perform the similar steps. Of course, you have to switch to the iOS platform, check, of course, if all dependencies are installed properly in your project. Now, I would like to show you how you can perform check everything. This is the same scene. You can find it in SCViewer SDK. Here you can, we will find a particular folder called Augmented City, containing another subfolding scenes. Clicking here, you can find the demo scene, Aug City demo. Clicking in Windows Package Manager, you can check all necessary packages. For example, AR Foundation, I install this version, AR Systems, Subsystems, and AR XR plugin. But of course, you can also choose another version. This depends on your PC, or you can, of course, update this particular version. And check this, you can also, for example, in a case, if you want to build for Android, you have also check here, in Preferences, you will find external tool field, and here you can check everything you need to build for Android. And now it's are ready to build our project, our scene. Clicking here, you open all active scenes. In this case, I have only this scene, and I can perform the build step. You have assign a name, for example, SCViewer test, and clicking building, you can generate your APK, and later you can install this APK in your Android smartphone. This APK will allow you to see any added existing content in previously scanned areas, places. just few minutes, and this APK will be in our PC, in my PC. Well, I am just waiting a bit because everything, I cannot press any button now. And this project anyway is very useful for you because you can start to from this scene to create something nice scenario to show in air modality. For example, you can also add in this scene some content. Here is your APK generated just now. I would like to show you now how create a scene. For example, there are, just to give you an idea, in ACView SDK, you can find also a folder called models. If you put this in your scene, you can also display in this scene. You can create, of course, any complex scene. This is just an example because I would like to show you how generating an asset bundle in order to download in runtime your 3D model. In this case, you have created an empty object and rename it in OBJ. Voila. This object will be, you have reset the position in order to put this particular object at the origin of the scene. Now, we'll add also a 3D object, in this case a cube, with place at 0, chords and with one scale equal 1. We'll use this object, this cube, only to fix the dimensions, the size of our content. In this case, I'll draw inside the OBJ my object, and now I resize the object and fix the position in order to put this object inside this cube. Of course, I have also to resize it in order to ensure that my object, my 3D content will be in a standard cube. And now it's enough to, for example, I can drag here my content in order to create a prefab. Now, I don't know if you can see, okay. The further step is assign a name to this bundle in this way. I selected the object, and here I'll choose new. In this case, I can type the name of the asset bundle. At this name, you can use the name that as you want. In my case, my bundle 2. Oops, I cannot type anything. I have just repeat the operation. Okay, my bundle 2. This is just an example. I select again, I'm selecting again the object and clicking to the right button of the mouse, I can see build a B, and now I can also choose the platform. In this case, I choose, I'm choosing Android in order to generate, to create my asset bundle. Just few seconds. And the bundle file will be generated. The same will be for Android iOS platform. It's very, very easy. And in this way, we can create any kind of bundle for any kind of 3D content, just using this sample scene. Well, show in Explorer in order to retry the proper folder where you'll find your generated bundle. That is this particular folder. I click in here. There are two folders, one for Android platform and one from iOS. Clicking for Android, I'll see my bundle. In this case, four kind of files will be generated. Our bundle, we need only this file without extension. And of course, the same will be for iOS. The name will be the same. So pay attention to the special platform that you choose to generate your bundle. Well, coming back to our my presentation, you can find sorry, you can find the steps just performed during the live demo, and you can see, of course, how create your content, how put your special object inside the cube, and here each step, the steps performed before to create the asset bundle. On the left, on the right side, I highlight in red color the bundle, the file without extension. Here, reporting again the source code. You can start to work with this, play with starting from this simple project. Thank you for your time.
Thank you, Michela, for your presentation. And now Gabor Soros will be talking about web-based client Sparkle.
Okay, so thanks a lot. And right now I'm going to talk about the Webxr-based client that we created as a reference client, fully open source for the Oscp. So I'm Gabor, but the code was mostly written by Michael Vogt, but also he helped out here and there. So I will present it today. This really became a kind of our hobby in the past couple of months. So why Webxr? Why is it good? You know, if we want to have ubiquitous AR, then we don't really want to have this burden for the users to install a native app on their phones or pick it out from their pocket. But it's really, with Webxr, you can have access to AR sessions from a web browser, and then you can have basically a constantly on, apart from like some camera issues and so on. But at least that's the ultimate goal, to have it always available everywhere without the explicit triggering. The problem is that it's really at the experimental stage right now. It's very limited browser support, only in Chrome and really only in Android. And it's even hidden behind some development flags that you need to enable. There is a problem that for privacy reasons, starting the camera access really requires an explicit button press. So we are not there yet with this ubiquitously available AR. But nevertheless, we created this client, which is available, which we call Sparkle, Spatial AR Cloud Client. Very funny name. You can find it in this GitHub repo. For this tutorial, I created a branch called ISMAR 2021. There are all the demos that we present today, and then later in the demo session on Wednesday. So we have seen this figure several times today already. We talked about these four green circles, and this is exactly the typical workflow that Sparkle follows, this client. So it goes to the spatial service discovery, then it retrieves a localization service, it sends an image to this localization service, gets back the Geopos, and then goes to content service with the given Geopos, and then queries the AR contents available, and then it shows them. So it retrieves the URLs, then it goes, it fetches those URLs and then shows them in the AR session. All these interfaces are hidden in some libraries that handle everything for us. And on top of this Sparkle general client, we implemented a bunch of demos that I will show today. And the original idea was that the whole platform is deployed in Bari, around the conference venue, and also in the city center near some famous places. So you could actually play with it. And now it's not so easy to show without being there, because all these experiences are really tied to the specific locations. So now I'm trying to show some things around the office here and faking my location actually. So setting up the code is fairly easy. So you only need Git, a node package manager, and a simple code editor, for example, Visual Studio Code. You can clone the repo, install the dependencies with npm. If you want to run this locally, because it's a website, basically the whole app, you need to create a certificate for your local host, which is simply done by this npx command. This npx is the same as npm, but it only temporarily installs the package and then removes it immediately. So it's only using this devcert package for generating these keys. And then there is a settings file, a config file, which you need to change if you want to use your local server, because location access in a website really requires a secure connection. So we need to have an HTTPS in the settings. Okay. Then once you need an Android phone with the latest Chrome installed. So version above 82. I think the newest updates are anyway about that. And you need to type here Chrome flags in the URL search window, and then you go to the experimental flags and experimental settings of Chrome, and then you search for Webxr, and it will list Webxr incubations, and this is disabled by default, and you should set it to enable, and then you will have access to this Webxr experiments. Cool thing is that when you plug in your computer, your phone to your computer with a USB cable, you can open a desktop Chrome and then just type in Chrome inspect, and then it will list your phones or the connected phones and all the websites that are open in an Android Chrome. So you can just press inspect, and then you can immediately see the screen and all the debug output of the application that is running on that website. So it's really handy. And you can start the web server with this npm run start. Make sure that your computer or the server and the phone are on the same IP address, because it happened that sometimes it tries to pick a virtual network address, and of course the two don't see each other. So this is just a note. The application architecture is listed here. So it's a Svelte application. It's just a JavaScript front-end framework similar to Vue and React. I'm actually also new to these, but it's fairly easy to get into the logic. Then Snowpack is used for as a build tool, so you can just edit your code, and in a second it will be live on your phone. It's relatively straightforward. We use a lightweight WebGL engine called OGL, but it could be we experimented with the Play Canvas and FreeJS, they are much more heavyweight, and we wanted to have something really minimal here. But feel free to extend it if you wish. Actually, this is also our goal for the future, to have more and replaceable 3D engines. And I will talk a little bit in the second half of the presentation about multiplayer, and for that we use a library called Purge. So the apps route is the main part of the code. Then there is a Webxr wrapper, which we created just for simplifying access to these Webxr features. Then there's an OGL wrapper, which could be replaced by other 3D engine below. And there are the OSCP libraries already integrated. So SSD access, SCD access, and Geopos access. These are the 3 libraries that communicate with the platform. Then there's the main viewer Svelte, which is hiding away all the complex stuff that happens. And on top of that, we try to make it very simple to create new experiments where you have only a simple API of something like 4 or 5 methods that you need to implement in your experiment, and then you can use this client and extend it further. And for this tutorial, we use AC for Augmented City for localization, and also the same for content services. But anything else could be here on this other side. We chose this obviously because they are located in Bari and they map the whole city of Bari. So in theory, the experiences that we would create in this tutorial would be available for all the conference participants all around the city. The app looks like this when you start it. So you can try it actually right now if you want. It's deployed for this tutorial on this address, sparkle.cloudcoast.io. It's important to use HTTPS. As I mentioned, for the location and other permissions, we really need the secure connection. The app will at the beginning ask for permissions for location and also for camera access. If you fail to click on OK, then you can still do that later. In this part, there's a small lock icon next to the URL window, and there you can set the permissions and Chrome. Then the first page, which we call dashboard, shows your H3 index, which is determined based on your course location. So we ask the course location based on the browser can give you a course location, and then from that we convert into an H3 index, and only this H3 index is used for all communication with the platform. I determine my country. I determined which SSD it should connect to, and right now only this US is available. And then you can switch between some modes where you want. Right now, this is AR Cloud, or it was renamed to OSCP mode. That's the default mode where you can query the OSCP services. And there are some other for experimentation. Here it found my Geopost service. This is how it's called, and the content server and the peer-to-peer server. And I click on, there's a button up here, which you can start the AR session. You have to move around the phone a little bit. So that the VIO initializes from like below Webxr, something like AR Core, and then it will place a simple object which represents the origin of the coordinate system, and then on top of that you can create your own content. Okay, so I mentioned the localization is the essential part, and these contents are the whole experiences only make sense when you are at the same location. And ideally, you map based on the previous tutorials from Julia, for example. You can map your street outdoors and just by taking a few hundred photos, and then in a few hours you will have this service available. What is important that even if you mapped the place, you need to register it in this service discovery. And if you contact us on Discord during the week, we are happy to help you with that, and then you can actually play in your own street instead of Bari. Okay. For a fallback, I created sensor-based localization, which takes the geolocation sensor and absolute orientation sensors of the device, or actually these are already exposed as APIs for the browser. The good thing is that then you don't need any kind of photos, you don't need any kind of visual positioning. So you can, this works right out of the box. The problem is it's quite inaccurate. So I experience here something like 10 meters deviations if I run this subsequently. And the coordinate system might not be consistent across devices. So for example, this is not good for the multiplayer. And I still couldn't figure out how the axes change when when I change the screen orientation. This is some mystery, which is seems to be different on each of the devices that I tried. But on the bottom part of the dashboard, there are these debug settings, and you can choose this geolocation sensor. And then this will overwrite anything, or it will actually jump back from the localization call, and no image will be sent. Another tricky part that was difficult to implement is camera access in Webxr, because for privacy reasons, there's no direct exposure of the images to the applications. So what I had to do is actually, but you know, everything is rendered as a background in the AR session. So what I did instead is I tap on the GPU texture that is drawn to the screen, which is kind of a hack, but there is no better way at the moment for doing this. And you can extract this GPU texture and package it into binary and put it in the JSON and send it to the localization service, which returns back the Geopos. Then there's quite a bit of math around the different coordinate systems used. So in the OSCP, you can use Earth-centered Earth-fixed coordinate systems. This was the one that originally Augmented City implemented. This has the origin in the middle of the Earth, and these are the coordinate axes. The Geopost standard is defined like this. So you have the local tangent plane approximation on the Earth's surface, and these are the axes looking east, north, and up. Then there is the orientation sensors API, which also uses east, north, up, but with a different labeling. And it's really not clear to me at the moment how these are defined when you rotate the device. And even if the device is a landscape or portrait mode, the camera might be back or the front. So we need to take all these into account, and I simply didn't have the time to implement all these cases. But right now it works on landscape mode, so please try in landscape mode. And Webxr has a coordinate system which is similar to WebGL, so X to the right, Y to the up, and Z backwards if you have a camera. The good thing is that it automatically aligns the vertical axis with the gravity already. This happens magically inside the phone. And there was an additional complication for myself, that augmented city cameras are defined similar to how robotic coordinate systems are defined. So the camera is always looking forward to the X direction, whereas in computer graphics and computer vision, this is differently. Usually the camera is looking towards the Z or towards the minus Z direction. So there's an additional conversion is needed there. Okay, so let's assume at this point we have the location of the device, and we want to query some AR content. We go to the Spatial Content Discovery service, and as I mentioned, Barry is already covered with both VPS and an SCD service. I show you an example result here. This window. This is actually part of the code, so that everyone can take a look. And if something, the network connection breaks down, for example, there's a debug mode where you can just return this result. This is how it looks like. So it has, this is the Geopos, ellipsoid height, latitude, longitude, and the quaternion. It says a reconstruction ID, so which VPS map it belongs to, timestamp when it was created, and this was the localization result, and this is the spatial contents. Augmented City can also return the two, so both the location and the available contents around you in the same request, so it spares a fair bit of communication if you allow this in the client. And then here you see some models that I placed around the place. yeah, orientations. These are actually in my own street. So this is how it looks like. Here's a new one that starts, and I show you how it looks when you actually start the app. So Augmented has this map-like user interface where you can place contents on the streets or around some famous landmarks. And this is how it looks like in their own application, all in 3D. So you can see from the names here, I hope it's readable. From the names here, you see that all these have differently defined orientations. That I made that on purpose so that I can see that when I query them in Sparkle, then I see that these boxes, the placeholder boxes, I don't have the 3D models, but the boxes have correct orientations. And the yellow and blue boxes, they represent the camera in the local coordinate system when the localization request or when the photo was taken, and the blue represents the global pose of the camera when the photo was taken, and the white box represents the coordinate axis east, north, up. So my street is looking towards east, and north would go in this direction. So this was a querying content. So how can you actually add contents? This is a more interesting part. So the content records can be, so you can add these to the spatial content discovery service manually through the Swagger interface that I showed earlier, but this requires authentication. You can also run your own instance, then you can do whatever you want with it. We also created a second instance called SCD Dev2, which doesn't require authentication. But since it's been running a week, it crashed several times already because people started flooding stuff in there programmatically. So contact us if you want to try, and we can give you the exact addresses. And for this tutorial, we also created an Amazon S3 bucket where you can just place a GLB file. And then this URL for the GLB file should be placed into the content record. Again, contact us if you want to try this out around your home. This was one example with this SCD. And the second example, if you use the content service from Augmented City directly, which is possible. And for that, there are their own tools. For example, this Web API that I mentioned, on the map-based Web API. But this is restricted to developers who take part in this tutorial. Contact us for this. But otherwise, you can take the Augmented City app, or you can take the XR Masters app that Ali presented earlier, and all these are compatible with the system. So you can just place these 3D models with the help of these apps. This is usually what I do. I make a map with the AC mapper, and then I take the AC objects tool and then place some objects, and then I switch to Sparkle, and I can discover those what I just placed. Obviously, they will just be placeholders because I don't. Sparkle doesn't have access to the models that are baked into the Unity app of Augmented City. So this is what I recommend to do. And there's a third way that I also implemented is just a temporary or programmatically defined content. So you can have, we have this simple 3D engine, and you can define primitives, and you can place them at where you actually want in the scene, either in your code, or you can just click in the user interface. I will show it in a second. The good thing about this is that these are so simple that they can be even shared between clients over the PTO network very quickly. And yeah, we would love to add a lot more ways of content creation, but this is really at an early stage. So as I mentioned, this is the AC object. Sorry, this is the AC admin tool. And here I created 2 objects around the office where I am currently located. And now I'm trying to show you how it looks like when I discover it. So this is the user interface of Sparkle. When I'm down on the floor, on the ground floor, I look around, and I press the localize button, and it sends a photo to Augmented City, and it retrieved the Geopos. Then it retrieved these contents and it placed them there. And these floating things on the right, these are the, as I mentioned, the coordinate system east, north, up, instead, I would like to show you the same thing live, so that you believe me. This is the screen of my phone, and right now I am not on the ground floor, but I'm on the 8th floor, and we have extreme sunlight here, so no VPS system would work from this height. But I will switch to the geolocation sensors. Here in the debug part, you can just click this geolocation sensors. Everything else stays the same. So I have the content service from Augmented City, Oscp mode. This is my H3 index, and I press Go Immersive. You can see my presentation. I have to switch to landscape mode, and I just press localize. There's nothing here to localize about. So it used the sensors, and it's successfully localized. There is one object, which was not shown on the screenshot yet. There's an OpenAI Cloud logo there, and then to the left, the duck and the ISMAR logo are floating there. Right now, I hard coded so that the geolocation sensors just return 0 height, so that I'm on the ground, because it cannot really determine the height reliably, so it cannot tell that I'm on the 8th floor. Usually this duck should be actually down there. Okay, so this is what I wanted to show. And now we can go to the next slide. You can also add some simple contents. This is actually Michaela in Bari placing an ISMAR logo at this nice fountain. But this mode, so you can select here content creation mode, but this is only temporary because Sparkle has no rights to write into the content discovery service. So it will just store this content locally, and then after you exit the session, it will be gone. But it's good for experimentation. So what you need to do is first do a localization, and after that switch to this content creation mode, and you can specify the URL, whatever URL you would like to have here. There are 3 models that are pre-baked in the code. These 3, ISMAR, ORC, and the duck model. But if you place something in the S3 container and then place that URL here, it should show up. It's able to load GLB models, but so far it cannot load the textures of those models. So that's why everything is just shaded based on normal vectors. And then this third mode, simple OGL content. So OGL is this simple 3D engine, and it supports placeholders, primitives from textual descriptions, like simple GLTF models, or an iframe content. So you can create more complex experiences which are packed into an iframe, and it will be overlaid on the actual user interface. In the code, you will find these model templates, JavaScript. It's relatively easy to add these primitives. What I did here is I created this experiment, which is already also part of the code, and this was specifically for ISMAR, is placing these ephemeral objects. So we localize with the visual positioning. Then the Webxr session can also give us a heat test, and the target point can be determined. So by Webxr or AR core, the heat test target will be determined on the floor, and it returns us the local pose in the AR session. And the origin of the AR session is wherever you started the app. Then I calculate backwards. I calculate based on a photo that we took, or the localization, where there we have a correspondence of the local SLAM pose and the global Geopos. And using that, I can calculate backwards what is the global pose of the hit point on the ground. And once I have that, I create a textual description, just a simple JSON with the shape, size, and color of an object. I put that into a proper spatial content record together with the geopose of the ground point. And then I pass this to the engine as if it was really received from the content service. And we draw this object by the renderer. And, you will see that even though this is not using anchors at all, because we have this geopose, we can anchor we can place the object to the right position, and it can actually stay there, and it can even be shared with another user, and it still shows up at the same place. This is an example video where I first localized in my street. There are some ISMAR logos on both ends of the street. So you see that there are some virtual objects. And then the next thing, I got this heat test from Webxr, and I click, and it determines the inverse where the heat point is on the ground. They are
You're back here.
I am back. I have 10 more slides. I would try to show them now if we still have time, but I think there is no hard limit at the end. I think officially it runs until.
Yeah, we can definitely continue, Gabor.
Okay, so let me try to share again. Now I won't switch on my camera. Maybe it helps.
Yeah.
Let's see.
Sure.
Okay, so the last video was about placing these simple objects that are generated. And now I'd like to show a little bit more complex content. This is, I would say, highly research grade. Let me put it that way. It worked once. And we are looking for more development support to get these properly done in this client. But we experimented with Play Canvas and also with Three.js. In Play Canvas, we can have interactive elements. The good thing is that Play Canvas has a web-based editor, so you can click just like in Unity, but really in the web. You can click together scenes very easily. You can have complex materials and interactive elements, and you can export this scene and import it into Sparkle, and then you can press these buttons. This content is not currently anchored with the real world. It just floats basically on top of the AR view. And something similar for Three.js. This was implemented by Mikkel, who gave the Geopost talk earlier today. This is something context-based. So here, when you click on the floor or on the ground, these signposts are generated. You can try to guess where he was located when he created this video. And he can add a new sign. And based on his Geopos and the ISMAR conference in Bari, a new sign appears on this signpost. This is also part of the ISMAR 2021 branch, but it's not fully integrated with Sparkle itself. It is just a Three.js overlay on top of the AR view. If you want to extend Sparkle with other functionality, and also these demos, what we show today, are part in this experiment mode here. When you click on experiment mode, a couple of experiments will appear here, and you can pick. If you want to implement a new one, then you need to define a name for this experiment in selector, so it will appear here, and create a settings thread and the viewers thread file, similar to the examples provided here. And all our demos are part of the ISMAR 2020. And the documentation, how to create these experiments, the details is written here, so I won't go into the details in the interest of time. And the last topic I wanted to show you is multiplayer experiences. Of course, this is much cooler to have in AR sessions. I extended this user-generated content demo to multiple users. So, and the idea here is that one user clicks on the ground, an object is generated, it is put into a spatial content record, and this one is, instead of uploading it to the server, is broadcasted in a peer-to-peer network, and other devices can receive that and then show, because they have the Geopos, even though they have completely independent AR sessions, So there's no joint session like in HoloLens or ARKit or like these advanced features on the Webxr. This doesn't exist. So they have completely independent AR sessions, but because the content arrives with the Geopost, they can show it at the same or almost the same location. And because it arrives with Geopost, to prove that there's no magical AR session, shared AR session in the background, I can place the exact same contents on a 2D map view on my laptop. So this is a normal Google map, and I can place the same objects appearing on this 2D map view. So it's not an AR session. The peer-to-peer architecture was inspired by a research paper and an article about this nice an article which is called a web application without a web server, and the idea is to have the same client code running for all the devices, but for both of the teams. Right now there's just one team. There is a long-running user who is basically maybe is running in the cloud. It has no user interface, but it stores and shares the same information. It stores the application state, and this state is getting synchronized all the time with all the new clients. So this headless client is also implemented now in Sparkle. You can try it out. There is a special mode how you can start this one in headless mode, and then that one will have the basically is only there for bookkeeping. It will store the application state and share it with the others, and this is how they are kept in sync. We use this AutoMerge library together with Peer.js, and all this together they are bundled in this Peer.js library, Purge library. The Peer.js is a peer-to-peer communication library based on WebRTC, and it's used for video calls and audio calls. And now we just send simple messages. And AutoMerge is a distributed document synchronization. It's similar to Git for multi-user document editing, and Purge puts these two together. And this is the library what we use. Okay, I skipped the detail here. This is how you set this up. And as I mentioned, this P2P service requires a headless client, which is somewhere in the network. For that, the easiest thing for us was to define this as a new type of service called peer-to-peer master, and this will be this can be queried amongst the available services in an area. So the URL, the peer-to-peer master service, is basically just to the headless client and the name of it, so that everyone else can connect to this one. And in my example, this peer-to-peer master Budapest is the peer ID of this client. If I start it with this, it starts in headless mode, and everyone else can connect to it. But I realized that there must be a bug somewhere, either most probably in my code, because the whole full history is not synced at the moment. So right now, if you try it, make sure that everybody joins the peer-to-peer network before the experience starts, and then it works. And the last video I wanted to show here, the right device already localized, the left device is localizing right now. They download the same contents of the street, the ISMAR logos, both ends of the street, and I had to be really creative to capture this video. But as you see now, they are both having a session, they're localized, and then I can start creating objects, and the same objects appear on the other device, although they are completely separate AR sessions. There is a little bit of offset, which stems from either incorrectly determining the touch point on the ground, or slightly misalignment in the localization. They are independent. And the same markers, I captured this afterwards. There was a third client running on my laptop in my backpack, and the same objects appeared here with these colorful markers. I wanted to show it on an iOS device. As I mentioned, there is no Webxr on iOS, but if you have an iPhone, you could try it. But my iOS devices had their course location so far away that it fell outside my coverage polygon, so they were never able to join my peer-to-peer network, even though they were also in my pocket. Okay, so that's all I wanted to show, and I would love you to try this out and even write us on Discord during the week and even after the conference. We are happy to help. We are happy if other people try to use this and find this useful for their own research, because with this, I believe you can have a big stepping stone to build a citywide AR experiences. And as a side note, we currently got a new funding for a project to deploy the system in Manhattan, together with or in the area of Columbia University. And we would love to get some more developers, part-time developers, PhD students just like us, to help us in the project. So thank you very much, and let's open up for Q&A. But I leave this links here. Now I try to switch on.
Thank you, Gabor. Yeah.
Okay. Survived.
That was good. Yes, we still have good audio.
Yeah, and finally we got to see the videos and everything, so that's cool.
Yes.
We still also have some diehard attendees who have been sticking around. So hopefully some of you are considering to try and implement something with these technologies, either web or native apps. Any comments or questions?
Even critics. It almost doesn't make sense.
Yeah, I was just out during the presentation of the my demo. Sorry if I needed to explain something and I was not here. But thank you, Gabor, for presenting it.
Yeah, and everybody, don't forget that there is a demo session about the same things with more detail on the videos on Wednesday evening.
Yeah, I will upload the latest version by then, so that you can actually try 3 years on Sparkle.
Let's put that time as well, and the exact CET time for that.
It's in the evening.
So there's no reason to be shy. You can type in the chat, or you could even unmute yourself if you would like to ask a question vocally.
Maybe Anthony Steed can explain what he's thinking of doing with students, as he wrote in the Zoom channel, in the Discord channel.
Hello. Yes. Hello. We've had a couple of projects to build 3D models of London and embed geo tools in them. So our use case is using a VR application to author augmented reality content that would be experienced in the street. So you don't have to walk around the actual city to create content. You can programmatically do it from somewhere else. So we've done that with very simple services in the past, where we've effectively served everything ourselves. So I'm just interested in how these things all fit together, and how you'd use the visual positioning system in the city. We were working with Scape before they got bought. Before they got bought, so their service got turned off one Monday.
Yeah,
and
it's a very vivid memory.
Some master students were very disappointed.
Yeah.
So the visual positioning system is a sort of set for me a separate part. So I will have a dig into how it all fits together, but I'm quite interested in using that separately from the specific serving of the information, because as I said, we want to serve it into VR and AR, not one or the other.
That's very interesting. This has been actually a topic many times in our working group that is looking into the development of the OSCP that the VR representation of the real world location is very useful. So having ways to experiment, to place content, and even connecting the two where there's somebody on the site in the real world, and then you have some people in VR, so bringing the two together. But you sort of, what are you doing for the geospatial part? Are you using some particular coordinate reference system that facilitates the geospatial part of it?
Yes, that's why I was being a bit annoying about coordinate systems. We've in the past have used OSGB, which is the UK national mapping system, because obviously it's much easier to locate things on a map than to rely on GPS, because you can measure in meters if you've got a local mapping system. And of course, UK is flat enough and small enough that that's possible. So we have built these things in the past, and I've got all sorts of questions about, registration quality, and that's hence the question to Michaela about how do you geopose the model, because the GPS is likely wrong. It will wander during the time that you're taking, especially in an urban canyon. So we've worked in the past on how do you, when we make these location-based services, I'm very interested in the geolocation, but also uncertainty, because when the clients come, they'll come with some error, and so one of the things we want to do, and it's a few steps beyond what I think is so far I've seen is reason about accessibility of the content if the visual positioning, if the positioning is inaccurate. So if you want to give a tour guide with multiple positions, how do you make sure somebody reaches them all, depending on if you have to resort back to GPS and so on. So I think that those are sort of the really interesting research issues. Yeah, so again, that's why I was asking those questions about registration and coordinate systems and so on, because there are many uncertainties depending on how accurate you want to be.
Are you still with us, Michaela?
Hi, Anthony. Can you hear me?
Yes,
Hi.
yes, yeah.
Probably I join later, so you can repeat your questions. You mentioned the accuracy regarding GPS positioning, right?
Yes, I mean it's only really a technical question, because of course if you survey GPS on a phone, it'll wander about anywhere from 5 meters to 25 meters to so if you're taking this over time, especially walking down an urban street canyon, you'll get quite a lot of inaccuracy. So the visual model is probably fine. It's just that you might want to tweak the location of it afterwards.
Yes, you know that GPS are not so accurate, and we develop implementing our localization algorithm allow us to precisely localize everything with also a centimeter precision. So of course, for this reason, we are able to localize in outdoor, indoor, even when it's very hard to capture the GPS signals, of course, because we use also CV. Our solution is also based on CV algorithms, computer vision feature. So our solution could be localized more precisely in respect to the GPS. I don't know if
yes,
I answer your questions.
Yeah, I mean, it was more technical than I think. I understand how they work. We did do some work with Scape before they were, but they turn visual position into GPS, that the transformation from your point cloud to the GPS is actually quite sensitive to WGS84 is quite sensitive to when the model was created, because the GPS when your model was created might have been wrong. So you just need to shift it. That's all. That's all. The only point is, you know, hopefully somewhere there's a way to tweak it a little bit.
You can try to use our solution, and of course, personally, I use it in a very critical scenario, and I was able to localize anyway my content.
And I'm just guessing, but if you have multiple images for creating this map or multiple GPS measurements, then statistically the model should be still aligned okay-ish. And then you can still rely on some additional hints, which I don't know about, but I guess you can reconstruct some parts of the scene and then look at, okay, how far are actually the building models from you, and align the walls with some existing maps. Okay, I think you can do tricks like this, but yeah, this is up to different in every provider.
Yeah, that's my experience of building location-based services in the past. There's usually a hack somewhere with an offset in it to realign the models, because, as you say, our process would be take the scan, align it to the UK mapping system, which is in meters, and then transform it to OSGB, to GPS, just because we choose the features to match to the map, and then the map we know, but it's not a linear transformation, so or it's not a simple transformation, because it's actually a complicated transformation.
Can you do something like trying to? I mean, you can align a few maps manually, let's say, and then try to find overlaps in those maps, and then like in a big puzzle. I don't know.
You can. It's not flat. That's the main thing. There's a local. It's very geeky, but it's a really interesting problem, because if trying to match national maps to say Google Maps is incredibly hard. Right, you'll be meters off, centimeters per kilometer error. So that's why the visual surveying is really interesting, because it's as long as you've got the location of your model, and if you've got a really large model, you might need to have to geolocate it at several points, just because it distorts so fast, the mapping. So that's really interesting, that it's so accurate. Yeah. Sorry, I don't want to.
Yeah, like the whole structure is based on many different local maps, and there's like an admin tool for Augmented City, where you can shift the point clouds around, and you can scale it and make sure it is as geospatially accurate as you can according to the map. So that is currently the way it is. So you can sort of do this block by block. Now I'm in this street, now I'm at this street corner, now I'm over at this street. So this allows for like at least local consistency, instead of having, there's not like one massive point cloud for the whole world. There is lots of smaller point clouds that combine to provide a service across the whole city or a whole country, for that sake, in the future.
And why this might be okay for around the conference center or around some landmarks, it probably is not scalable for a city like London. So if Anthony, you have some PhD students interested in this topic, then we are happy to collaborate.
Yes, well, I have an active project on this. The sort of interfaces with a smart city project. So
excellent.
And we have worked on 3D models.
Yeah, and the whole idea is, for the platform, you can just swap in any other positioning service. So if you have your own, you could extend the OSCP with your own system and experiment with it, and even compare it with the others.
There is actually a university that is planning, George Mason University over in the US, who is planning to do their own open source implementation of a Geopost service. And they also very keen on doing comparisons between different providers of Geopos to explore the accuracy, like how does Augmented City compare with Immersal, compared with their open source version, so that you could sort of have testing grounds where you know the on the ground facts, you know what the Geopos should be. And then you can compare that with what the actual Geopos, what you get from the service, from the actual services. So there's that's a really good thing to look into, to know and compare between the service providers. Yeah, and push the limits of what you can do with new algorithms. One thing I'm hoping for is going the semantic approach, doing object detections, having constellations of objects that are in arrangement with respect to each other. And the interesting part about that is you're less vulnerable to lighting conditions. So if it's winter, if it's summer, if it's dark, or if it's in the middle of the day, you recognize the same objects in the scene and use that as a way to localize. So there are many approaches to be explored. Anyways, you could reach out if you are interested. We're going to try and put up some more details about the R&D, paid R&D opportunity, but you could send, if you're interested, initial message to this email, info@OpenAIRCloud. So we can take it from there. I'll try to see if we can put something out on the Discord server for the conference, and maybe we can put something up on our website, openaircloud.org website. And of course, we're always open to any volunteers who care about these kinds of things and would like to just participate and learn and be a part of the community. One question for Anthony again. Is your project, the VR thing, is it open source?
AC viewer?
No, for Anthony. The
okay.
VR project, is it open source?
It's not currently, but some bits of it are. Some of the tools that we built, also online synchronous AR to VR through an open source toolkit, which we made. This is called Ubiquitous, but we're talking about it at another conference. The mapping, the models, it's obviously a very difficult question. So we have made 3D models. Whether or not we own all the assets that we can give them away is another question. Because they're not, so yes, the project could be open source with all the live connection and the sort of how do you do it in Unity. So for example, we have in VR location services wherever you want it to be, right? So you just have to come up with a way of making user interface that allows somebody to place themselves on a map. We could make that open source, but of course the easiest way for us to build that is just use one of the paid assets like Mapbox. So of course that then makes it not open source. So it's more of a case of building the user interface tools that allow you to describe positions in VR and AR, by the way. Because I think most of it'd be nice to be able to indicate position as well as just read it from geosensors and the visual positioning system. so yeah, whatever we can, but that is our normal mode. But unfortunately, when it comes to models, there's a lot of proprietary data out there, which we can't share, unfortunately.
Yeah, the software is sort of the maybe the most interesting part, so we can have transfer maybe some of that to another location, maybe use it in Bari, maybe use it somewhere else. Regardless of that, there are some partners of OpenAir Cloud that are located in the UK, and some are, I think, working from London. So there has been some discussions around setting up a proper test bed in London. So maybe from your own university, you could start that out yourself, firing up a sort of like a campus test bed.
Yes, I'd be very keen on that. That's hence my question at the beginning: who can run one of these servers? Because that will be eventually, the content discovery will be a bun fight, is the English expression. Like who actually gets authority and who gets to say the ownership of polygons. We have a nominal authority for that in the UK, which actually called an Ordnance Survey. I saw them on your slides. It'd be interesting to find out who you've talked to there, because they are the mapping.
That's the guy.
Jeremy, I know Jeremy. Yeah,
you know Jeremy.
I know Jeremy. He's associated with my university, so he's a vibe. Is how do you actually? Because somebody will try and claim the whole of the UK. So you've got to be able to prevent that.
Yeah, so it doesn't make sense. Like it doesn't make sense that some.
And then how far do you want to break it down? Do you, and then do you? And a couple of previous AR companies and geolocation companies have struggled with that. Just how do you? Who gets to be the domain server for UCL? And how do you monitor that, and or any company or any government, or so the granularity of that, and then also the query structure, so you don't fall into the same problem that Layar had, which is they ended up with just hundreds and hundreds of overlapping maps where you just had to say what your interest was before you started querying, because otherwise you get too many results. So that's also very interesting.
That's a super interesting topic, and Christine Perret has sort of, I think even before the OpenAir Cloud was founded, she has been working around this concept of continuous semantic search. So you have a context around your location in the world, but you also have like a personal context, and like what are your interests, and what's your current situation, what are you up to, all of that. Currently it's Google and Facebook that is trying to build that context on you. That's not a really good deal when you're moving into the spatial computing era. It's better that you have your own context and you have control over the data that builds that context. And alongside that, it is sort of like an obvious thing to imagine an AI agent acting on your behalf, making the proper types of requests that is relevant to the situation you're in. So that's a super interesting R&D topic. How can you facilitate, as you're moving through the day, as you're moving from this context to the next context, what is actually the things you might be interested in? Are you now a commuter? Are you in your workplace? Are you having some fun in the evening? Are you at home? All those very different contexts. An AI agent acting on your behalf, knowing your data, but not sharing it with Facebook or Google, should be able to use something like the Spatial Content Discovery Service to make sense of all the stuff that is available. So key here is having metadata on the spatial content records that facilitates these kinds of intelligent contextual search. So we won't know 100% sure how this will play out, but better it's not like an open platform like the web, rather than locked up inside some big tech company that doesn't work together with the other big tech companies. So we have a plan now. We're gonna help you set up some OSCP servers in your campus and go from there.
Yeah, we'd be happy to do that. Yeah. And,
awesome.
And then yes, and I'll email this link below and just see how we do that. Yeah, I have another. This project is doing something in London and also something in Cyprus. So we'd have a. We'd actually want to set up two, because we're prototyping things and then moving them out to Cyprus. That's the idea. Yeah.
Cool. There's one nuance. So at one location, you might have multiple content providers, those spatial content service providers. We don't want those to be sort of fragmented and show only like you have to like use this provider to get those things, and then my friend registers some content over at this provider, and then my company has this, and you want them to work a bit like the when you're typing in a URL. There's a registrar that if you have a company, you register your domain name at one registrar, but there are many other registrars, but it all combines to the same system. So if I put in a domain name in a browser, it doesn't really matter who was the registrar, it will just work. And we think this principle should work for the public content records on the spatial web of the future, that you have your choice of registrar and you have your choice of service provider, just like a free and open market. And on the top level of this, there might be some sort of foundation that has some responsibility to make sure that the service providers in an area, that they're complying with, the legal, ethical kinds of regulations and best practices. And then it's sort of up to each registrar to offer great service under good terms and be in compliance with the law of the land, with what we the people want for a location, not what some people over in Silicon Valley has decided.
I think this gets to the crux of we don't know how to do that. That's sort of asking. At the moment, we go to a website which filters data for us automatically, and we just have the choice to go to multiple ones and switch our attention between multiple apps. So that's and if you want to integrate them in the same, if you've got the geographic information, obviously has a different sort of key, which is your location. So how do you moderate between those two? Is really I don't think anybody has how to switch between the providers it's basically at the moment, as I see in OSCP, who do you trust? And you'd have to select people that trust, and then you use their filter to sort of lay out content for you. So that seems to be the way it would work at the moment. And that might be viable. You just have to, you've got a slightly different thing which doesn't exist at the moment in content, which is with somebody which is a service provider, which is providing a sort of usable sort of filter on everything that's out there. So you might have a service that register absolutely everything that's on is giving geolocation, but it's strongly filtered in order to get you only a tractable subset of it.
Another aspect, another nuance is that it's a distributed kind of project, because the data is valuable near the user. That means that you'd have some local spatial content discovery service operators and registrars in your city, but they're providing services there and maybe not providing services in another country or in another city. So you have this So the balance there, like, do you want like to have a million different providers, or do you want like a like we have telcos? I think there's like an overlap with how telcos work. We have local telco providers, they have local infrastructure. It's sort of a mapping there. They're building out their telco infrastructure, and you have your subscription for 4G or 5G. And you don't have necessarily the same telcos all over the world. There are some like global players in that market, but still there's a lot of local players. And I think that could make sense in this kind of infrastructure, that there are some people who knows better how the laws and regulations work in this country versus that country. It's quite a stark difference between Norway or Singapore or China or other localities.
It's quite good fun to think of like applications you don't want. I don't want to go into my local supermarket and have their competitors label everything with lower prices, right? Because that's easy to build with the services you've got here.
Yeah.
It's just that obviously if I'm going Tesco, they want me to. They don't want that to be available, and I do. But it's arguable whether or not similar systems have existed in the past, made by consumers to do that type of product, and they've been banned. So that gets down to some very interesting properties of what is a physical space for, and in some cases, in supermarkets, part of it is denial of the price comparison. So,
yeah, that's a here one. We're on the property of somebody else. So
yeah.
Different jurisdictions might have different ways of regulating that. So that could be very different in the UK versus Norway versus somebody else, some other country. So
yeah,
but I think it doesn't make sense that like OpenAir Cloud should decide for all countries, or that a specific company in Silicon Valley should decide. That is, that would be not good.
Yeah, and generic, what about the possibility of making the device its own very own Oscp server and have it a direct communication between the devices without having to access any other server? They are not regulated by any other authority. It is a communication between two devices, between two people.
Like the open decentralized approach. There are
exactly.
Yeah, so those things are obviously interesting to explore, but they're you still in a country you might do something that way that might not be legal. So regardless of how you slice and dice that, it could be good, or it could be bad, or it could benefit the user, or it could benefit a big corporation.
But if for example, I make a swastika in a graveyard, one of those things that is the case for the do not augment in a graveyard. But it is something that I only share with another person.
Yeah. Okay. Yeah. So the distinction here is between the public spatial web and a private spatial web. If you have sort of like private spatial web features, that is your private communication with another person going on over a encrypted channel. That is the form of, I think it's a vital thing in a liberal democracy to have the ability to communicate with others fully, freely, without being surveilled. So it has a room, but for the public part of the spatial web, you will encounter the police, right? It is. So if you're expressing something that is regulated by how in that country, that like in Germany, I think the swastikas are likely they're forbidden in general. You cannot just throw out a swastika, and you'll be put in jail or something. And in general, I think,
But again, it is the issue that if we allow a complete peer-to-peer architecture, and people decide that the public is like their group, like 1,000 people. Is that part of the public? That is the question of where the beginning of the private space begins and when the public space begins. And that is something that I believe we have to address sooner or later.
You are just inventing here the dark spatial web, I believe.
Yeah.
But back to the providers question, whether who should actually do the filtering. If you think about the web, it's quite successful, and there you don't. You actually, I mean, there are so many websites there, and you can go to any of those websites, and it's not your internet provider who selects you those websites. You can have content filtering on the client. You can have ad blocks and things like that on the client, but everything is available to everyone. Everything is discoverable to everyone, or almost everything. So in that sense, it shouldn't be the providers who do the filtering for you. Maybe you can do similar to a news subscription. There can be some providers who select some things for you, and you can pay for that. But in general, everything should be discoverable by everybody.
Yeah, there's definitely, I think there's lots of business opportunity around content curation, where there are entities that helps their customers like filter and get to the highest quality content. So like imagine you have Disney. They're like a content producer, and they have they have sort of curated their own universe of stuff that a group of people fancy, the stuff that Disney created. And so imagine Disney creating stuff on the spatial web. Now that is by just going for that provider of content, then you can have certain expectations on the quality of that content.
Yeah, but will not Disney try to force this kind of content provided system instead of peer-to-peer? Like Disney will pay.
Oh yeah, Disney, they are all about copyright, right? So they're not gonna like anyone copying their IPR for free. So
yeah,
OpenAir Cloud is not here
to
make all content free for everyone.
Yeah, but they will try to push us so that they have a better competitive advantage. And we have to deny that, and that will be a very difficult topic to talk about. It's like I can imagine that Disney or any other company, even they will not allow smaller companies to have actual competition with them. They will try to create their own closed ecosystems, like what is happening right now with Netflix and Disney Plus and everything else. It's like they want to control the ecosystem. So how can we maintain both positions, like the public and close and open ecosystem?
Yeah, I don't think that OpenAir Cloud can do magic. What we can do is we can advocate for an open platform where everyone is free to register their content. I'm not saying that it should be free as no cost, that everyone just should expect that it's a human right to publish 1 billion different content around the world without paying for it. That's not what we're saying, but you should have, just like you can go and buy your URL domain for your company and you could build your own website. It should be a similar situation, that nobody can just prevent you from putting content out on the web as long as you're not putting out illegal content.
Yeah, but I cannot create my own ICANN and start asking people to give me money for domains. So where is the limit?
Well, it should be very much cheaper per content record than per domain, because instead of it being like a top level, here's your company URL, that's like one of them. But for a content record, it doesn't make the sense to have the kind of pricing levels you see in the world of domain names. So I agree that it's really annoying that domains should be so expensive to buy. But imagine then that the service provider that provides the records, they can be told by the police to remove a record. So they become responsible as a business to the jurisdictions they are operating within. And that has a cost to manage. So I'm not going to expect that any company will provide that service indefinitely for free.
Yeah, it's just this kind of difficult questions that someone has to ask, but I will stop right now.
Well, this was a good discussion, though. We touched in on very interesting topics. Okay, maybe people are ready to have their dinner or something. We've been going on maybe over time now, so maybe we should wrap it up. Any final questions?
Yeah, please contact us during the week if you would like to try the code, and see you in the demo session.
Okay, with that, I salute you with the live long and prosper from Star Trek. So have a good evening, everyone. Bye-bye.